Okay, hold on. Give me a moment. Oh shit, forgot to write a post for Blue Sky. Going live with some mesh optimization experiments. Something like that. Okay, post. There we go. I have sent the tweet. Hello. I need to figure out a better place for my microphone. I feel like it's never in a good spot. I kind of want to put it like so that it's above the monitor, but like the further away it is from me, the more echoey and the more noisy the background's going to be. Where's Cat? Right there. You can see the fluff. I don't know how to point. There we go. This is Salad's tail right here. Salad's napping in a cat tree. He might get annoyed if I do this too much. Or maybe he doesn't care, actually. I don't know if Salad cares that much. Oh, he flipped. Oh, he turned around so that his tail is not quite on stream anymore. There's some butt fluff here, though, so you get some butt fluff. How are you? Kindly answer me. I'm okay, I think. I believe. Let me just get set up. Minimize the windows. What do I have open in Photoshop? My notes? That makes sense. And I believe we are ready. Close. Okay. Okay. Let's see. Gotta open the project. I'm still using the security exploits version of Unity. The, what's it called? Unity's launcher? Is it called the launcher? Hub, the Unity hub. It's yelling at me because I haven't gotten the latest version. Okay. So today I wanted to look into a mesh optimization thing. And what I mean by optimization, it's not like performance optimization where I need to, make something perform faster when it comes to computation, but more so optimization in terms of optimizing geometric properties based off of some constraints. That's what I want to do. So one common example for this is something like for example, let's say if you're familiar with 3D modeling, when you're unfolding UVs, like you have a UV map of a mesh and then you're doing an unfold or relax, depending on the terminology, that's kind of an optimization problem where it's trying to optimize the UV coordinates based off of some desired constraints. And those constraints could be something like let's say this is a UV map or something. Like maybe your constraint is that you want the area of every single face here to be about the same. Maybe that's a constraint. Or maybe you have a different constraint of you want all of the internal angles of a face to be as close to 90 degrees as possible. So this is kind of like that's an optimization problem in terms of mathematics. I think it's called an optimization problem. Although in computer science, optimization usually means something else. But yeah, so that's something that I wanted to experiment with. I actually don't have that much experience doing stuff like that, and so I kind of wanted to experiment with it. That's why it's called an experiment, because I don't know if it's going to turn out well in the end, but that's part of the fun, I think. So yesterday, I didn't stream yesterday, but I did set up this little test scene where I'm kind of ready to start experimenting with the optimization stuff. So this, let me just center this, otherwise I'm gonna lose my mind seeing that be offset. So this is kind of the same situation as we had before, where you know, we have a tessellated triangle like this. Why is your mesh of tetragons instead of triangles? So this is because in 3D modeling, quads are very, very desirable. Well, quads or squares or tetragons. So this is called a quad in 3D modeling. Quads are nice for many reasons, but one of them is that you get something called an edge loop and an edge ring. So an edge loop is, you know, a set of edges that go in a path between quads, right? So like this is a quad, this is a quad, this is a quad, this is a quad, and so forth. And so this is called an edge loop. And then there is another concept called an edge ring, which is basically the parallel edges you have here that are among connected quads. So this is, it's desirable in terms of the workflow of making a 3D mesh as an artist. But of course, in the end, it's all going to be triangles on the GPU. So every single quad is going to be broken down into triangles once you export this to some mesh format, right? But it's just that quads have a very, very nice workflow when it comes to manipulating a mesh and like creating a 3D model. So that's something that's just desirable for a 3D artist when working with meshes. So it's kind of like a whole science in and of itself. But if you do a lot of like character work or like high poly meshes, or not high poly, but like hard surface meshes, like all of these things is usually something you consider part of something called edge flow. And so you know, the quads are something that encourages good edge flow of your model, because you can kind of see the quads form this kind of nice flowing kind of thing, where all of them are connected in a pretty predictable way. But this is of course broken up here by the triangle. So the flow is broken up here, but for all the rest, it's intact, right? Yeah. But since this is a 3D art application that's made for 3D artists to work in, what I'm generating here is specifically trying to make quads as much as possible. I guess I can show you in Engine now that we actually have, now that the bevel actually works, I can show you what it looks like. Let me see if... Wait, did I break something? Hold on. Did I seriously? Hold on. Oh, what? Unity? Get your shit together. Wait, I'm so confused. Why is my rendering messed up? Oh, you know what? I think I know why. Hold on. Is that it? That is it. Okay. That's okay. Cool. Cool, cool, cool. Now it works. No, it's, okay. Trying to figure out how to explain this. But basically, Half-Edge, the 3D modeling tool that I'm making, doesn't use Unity cameras to render. But I do use some of the shader properties that cameras set on the GPU. So that's stuff like, you know, the rectangle on screen has to be like data that's sent to the shaders. Stuff like the projection matrix, the view matrix, stuff like that. And I think because I was in the scene view and I had an orthographic viewport, I think it's broken because my shaders here are not set up to work with orthographic perspectives. And I think some of the properties that I make use of in my shaders rely on it not being orthographic. So, and it's probably just using like whatever camera set those properties last is what it's going to use. And because Unity's scene view camera is, you know, it's the same type of camera as you have in game, it's setting the global shader properties in the scene view. And so as long as the scene view is perspective, the game view is going to work. So I think that's what's happening. Which might also actually be why my camera-based selection is broken. Okay, it's actually working now for this particular case. Okay, so now my camera-based selection is fine for some reason. Okay. Interesting. But it was broken yesterday. Fascinating. You learn new things every day about your own application. Camera-based selection is basically you're only able to select the stuff that you can see in front of you, and anything that's hidden behind something is not going to be selected. That's camera-based selection. So, for example, if I create some obstacle here and then try to select, you can see that it's not selecting the vertices that were obscured by that object, right? So that's camera-based selection. And because that system is largely GPU-based, if some of the global shader properties are wrong or like set to some incorrect values, camera-based selection is going to not work. Usually it would like select stuff that you actually can't see, which it still does here to some extent, which might depend on zoom level actually. Yeah, if I zoom out and select, you can see that it's still selected the stuff behind of it. I think that's just because there's some kind of, like projection matrix that I'm not updating when I should, so that the depth that I'm reading from is read or written to incorrectly. But it works when I'm zoomed in, so that's good. And the alternative is to not have camera-based selection. So turning that off, you basically have a see-through, you select stuff behind it as well. So then it kind of pierces the whole mesh. And this type of selection is a lot easier to implement because you don't need to do any kind of intersection testing. You can just kind of just do a screen space test, see if the thing is inside of the box or not. But yeah, this also applies to stuff like faces. So faces also support camera-based selection and edges as well. I'm really happy how this system turned out. I'm glad I spent the time to make this performance, because like it's kind of nice that like it's so performant that I can just select this amount of stuff, no problem at all, and it's all dynamic in real time, or subtract from it or whatever. I think it's super cool. I'm glad this is working. Is there any tool out there having camera selection? as in not selecting stuff behind objects. I mean, most scene editors have that. I mean, actually, does Unity have that for box selection? I'm not 100% sure, actually, but I'm pretty sure Maya does, Blender does. Usually it's a setting, like you would toggle a camera-based selection. Okay, so I was going to make a point. I was talking about the quads. Oh yeah, like why quads might be useful. Well, so for example, does this work? I hope this works. So let's say I have this geometry here, and then I insert an edge loop. So inserting an edge loop will generally create quads. It just kind of wanders along the mesh until you get back to the beginning or the end of the mesh, and then you've inserted a bunch of vertices and edges there. And once you have a bunch of quads like this, actually, let me insert some more edge loops because why not? So now you can do a bunch of selection actions here. So if I double click on this one, because I'm using quads, because there's like an edge flow here, it's very easy for me to like double click something to get a, to catch an entire edge loop. And then you can just move that around or whatever you want to do with it. The same thing goes for edge rings. So if you select that one, I don't have a shortcut for that right now, but then you can select kind of the opposite, the parallel version of it rather than tangential. So this is an edge ring. And so with all of this stuff, you have a much easier time manipulating the model. Same thing with faces. I can just kind of, well, if my tools work, you used to be able to do this. Did I break it? I might have broken it. Okay, well, I broke my face ring selection, but I do have it. Is it this button maybe? Oh, it is. Okay. So, I don't know, just being able to select all of these is really useful. So, I don't know, maybe you want to extrude all of these edges because you want to create like this brim type of thing around it or whatever. So like edge loops and edge rings, super useful. What would the edge loop look like on a weird shape like a cat face? So an edge loop is a purely topological operation. So generally, I don't know, if you have faces, for example, you would have some kind of geometry around eyes. So let's say this is an eye socket on a character. You can sort of see, usually it's some kind of geometry like this around an eye, right? So like an edge ring in this case, that would be this connection here. If you select this vertex to begin with, the edge loop would go around like this, right? But if you instead select an edge ring, then if you want to get the ring from this one, you would get this and this edge. And so edge loops and edge rings is basically a way to structure your mesh topologically so that there's a nice way to catch certain selections like this. There's also some other properties. I think it also helps out with making sure that normal interpolation is about as consistent as possible. And so the goal is usually to, you know, when you're making a character. Now, I'm not a character artist. I would have to get my sister on stream because she's a character artist. So like if you wanted to have another eye next to this one, if you wanted to keep on sticking to quads to, you know, maintain flow, then, you know, you could connect this with another quad like this, and then you would start the next eye socket here, right? etc. Yeah, depending on what you do here, you can have multiple quads here, or however you want to set it up. It depends on the geometry that you want to approximate. But as you can see, like, I'm only using quads here. I'm not using triangles anywhere. Yeah, so that basically helps with edge flow, and it allows you to do a bunch of selections that you otherwise might not have been able to, which is kind of cool. And this is purely a topological property. This is not based off of, it's not based off of, like, you know, we want to get the next edge that only has a certain, like, angular deviation from the previous edge or whatever, like based on a dot product. That's a different type of operation. So edge loops and edge rings are purely topological. They don't care about where the vertices are. It's only based off of the connections. Yeah, so that's how this works. So I'm not using pathfinding, no, and I'm not using a smallest path or whatever. It's purely topological. Would there also be a beginner tutorial in your software? Yeah, I think there's going to be, I mean, I don't know what form it's going to take, but I'm designing this to be nice for people who have never done 3D modeling, but also nice for people who have done 3D modeling before. A pretty big goal with, you know, one of the big reasons I'm making this in the first place is because I want to have something that's a bit more user-friendly and less intimidating. I keep comparing this to Procreate. It's a drawing app on the iPad. I'm basically trying to make the Procreate of 3D modeling. So if you've used Procreate, then you know what I'm sort of aiming for. So that's what I'm trying to do. And whether I'll succeed, no clue, but that's okay. Are you using a high-end gaming computer or more or less a consumer level? I don't know. I mean, probably it used to be high-end at some point. I don't know about it anymore. Would you consider implementing any non-destructive operators, or is that too much work? I think right now I'm not doing anything non-destructive because it's a big rabbit hole, and I have a tendency to get stuck in rabbit hole like a bug light, and I need to make sure I'm focusing on the important parts first. And if I start dipping my toes in the vast chasm that is, you know, procedural generation, that's going to take a lot of time away from making sure I got the basics working. So I'm focusing on the destructive parts first. And also just from like a philosophical perspective, I've kind of, like, I don't know, I like it when things are handcrafted. And in the age of AI, I think this is something I want to try to push a little more, ideologically, I suppose, or philosophically. So, I mean, I love procedural stuff. I hate AI though, like generative AI, that stuff I think is garbage, but I do really enjoy procedural stuff. I've done that kind of stuff. I've done a lot of, like, I don't know, like procedurally generating meshes along splines, even like, you know, non-destructive operators, like sub-D meshes, like stuff like that is super useful. But the big issue for me right now is that I haven't designed the way that it should work in half-inch. And I think it's not necessarily required for most, like, low to mid poly art. I think if you do stuff that's like AAA or high poly, and you need to have like really high poly, like hard surface modeling, or you're doing like terrain stuff, like, then you kind of do need some kind of procedural stuff and non-destructive workflows. But I think I'm just gonna not focus on that for now. I think I want to make sure that the the manual workflow is as nice as possible before I move on to those things. Yeah. And also because yeah, I have a tendency to get stuck in rabbit holes. Like, if I start making the next like geometry nodes, but for in half edge, that's like, it's gonna take a lot of time. And I think that's less important than stuff like having the ability to have multiple objects in a scene. But multiple objects is like a much less interesting feature. But it's more important for me to work on it. So I don't know. I have a lot of reasons to not look into it right now, but it's obviously a huge drawback to not have that kind of stuff. But I think I am intentionally not, like, half edge is not for like AAA high poly game development. I think that audience, that big crowd of AAA development, is just not part of my target audience right now. I think my main goal, that's why I'm calling it a mid-poly modeling tool, because it's sort of more targeted towards indie developers who are not gunning for the most like high fidelity art possible. And I think for that kind of stuff, you don't actually need that many tools for that. You don't need every single like procedural stuff that's out there or every non-destructive workflow. And I feel like sometimes that can even get in the way, much like in the same way that like when you're a programmer, trying to generalize everything you make into this generalizable generic type that can handle every edge case, that can often take longer than it would take to just implement the 4 things manually rather than having a generalized system. And there's like parallels to that in 3D modeling as well, I think. What does purely topological mean in code terms? It means that when I want to figure out, like, because when I'm selecting this edge, and I want to figure out what are the other edges in this edge loop, that's a problem I need to solve, right? Like, I need to figure out, okay, starting from this edge, how do I get all of the other edges here? And, you know, I could do stuff like, okay, so let's say, you know, we have a vector for this edge right here, and then we can check, you know, the neighbors. Well, okay, so around this vertex right here, we have a few other edges connecting to it. So maybe, like how would we define an edge loop? So clearly, this is the wrong answer. We should not go along this one. But why? Like, how do we define that? Well, one way we can do that is to kind of like do like a dot product to like check the flow of this, and be like, okay, so maybe the angular deviation or something, and if it goes, if tangent to the surface, if it turns 90 degrees to the left or to the right, we're not going to do it. But if it's only turning up or down, then we can grab the next edge. So then the heuristic would be, for every vertex, or for every outgoing edge around this vertex, check if it would go up or down or left or right, and then based off of how the angles you have there, you would select the next one in line. This would be a spatial way to do this type of selection, not a topological one. So if we instead consider a topological way to do this, it would be something like this, where you have an edge, and then you have the next vertex, then you check the number of outgoing edges in that vertex. If it's 4, meaning it's a node, it's a cross where it's got 4 faces connected to it, 4 edges, then topologically we can just say, okay, we get the next edge in the sequence, and then we get the next edge after that, and then that's our next edge. And notice that this type of iteration or traversal had nothing to do with angles. In other words, it's purely based on the topology of the mesh, not based on directions or angles. And so basically what that means is that even if this edge were to point like directly to the left, it would still select that path, because it's not based off of spatial properties like angles or directions. It's just based on the topology of the mesh itself. So that's what a topological traversal is. How would you even distinguish up, down versus left, right? Well, using dot products and cross products, pretty much. So like, if you have this vector right here, the dot product between that vector and any of these two vectors would be very close to 0. And then it would also be 0 here, but then if you also do the cross product, and based off of the phase normals, you can then get a distinction between these two. So with dot products and cross products, you could get kind of like a separation between up, down, and left, right, which would be kind of like, you know, you can use dot products and cross products for decomposition. And it's kind of like, the dot product is kind of like your cosine, and the cross product is kind of like your sine function. And so those two give you the two directional components for how it's turning. So it's definitely possible to do like that kind of spatial continuity check. But yeah, you would need to construct some kind of coordinate basis for that. And I think you would use the phase normal probably. Because otherwise the dot product between this one and any of these three would be 0 for all of them. So you need to distinguish the vertical one somehow, which you'd probably do with normals. Okay, I need a drink. What about 3 edges? So that's kind of the downside of the topological traversal. So if you have an intersection with 3 edges going out of it, then generally you would consider that the end of the edge loop. Like you don't continue traversing. So like now selecting this edge loop, it terminates here. Like it doesn't continue here because this is no longer a place that branches out into 4 different edges, right? And so the topological method stops here. Even if you were to like move this vertex, so it would sort of look like it's continuing the same edge, it's not going to select it because topologically it doesn't have that type of branching there. Yeah. Does any modeling tool issue the spatial method? Probably. Yeah, usually there's some kind of selection thing of like select next, and then you have like an angular threshold. Okay. If you have one suggestion to give to help generalizing rules for beginner programmers, aside from trying to keep things as simple as possible, what would it be? It's so hard to give general advice. I feel like so much of programming, at least to me, I have a very hard time taking programming advice and like programming pattern stuff into advice until I run into the need to have those myself. So like, I don't know, I feel like it's really good to make mistakes and learn from them, rather than someone telling you that you should do the solution to that thing you would have learned on your own. It's kind of like the learning by doing approach, which generally helps a lot. Like, people can talk all day about what type of programming patterns are useful, but if you've never, like, faced the consequences of not using that pattern and the pitfalls that has, it's really hard to, like, at least for me, to internalize that issue and like actually see the full scope of the problem space that it's trying to solve. Yeah, I feel like it's usually better, at least for me, to learn that way. Otherwise you can run into the mistake of like using programming patterns before you even know that you need them. And so like once you've done quite a lot of coding, you start getting like a sense of, like an intuitive sense of when you're starting to go down a path that would lead to bad code. I think usually this is what people call code smell, I think, where like you're kind of sensing that whatever structure you're doing is wrong. And the more you do programming, the more you're gonna feel that intuitively. And that can kind of only really come from experience. And so get experience and do stuff and fail and pay attention to when and how you're failing. And then only then you can like properly learn how to get past those specific issues. Okay. The best way to get started is to just start. Unfortunately, yes, that is usually the case. Are you following some papers or documented algorithms? Generally not. So, well, I did try to read up on some of the, I did for the Bezier patch stuff. Or I guess the Bezier patch specifically was just Wikipedia. But when trying to solve the problem of filling a hole, basically this thing of like, given the corner of a bevel, how do you make a surface spline that fills that hole? And that is a complicated problem. So that one I did read up on a bunch of papers and kind of failed at implementing some of those. But then I decided to just solve the triangular case first, because the triangular case is kind of tricky. The square case is easy. This is the happy path. And then I think all of the other ones following that can be broken down into either triangles or quads. So I only really need to solve these two cases, and then I can disassemble any like higher number of polygons into either triangles or quads, and then interpolate on those two. So that's kind of my plan right now. So yeah, as you can see here, like this pentagon, like you can break this pentagon down into quads, and then I would use the square patches here, the square spline patches. And although this one has like subdivided in the middle, but I mean you can also, like if I were to do this tessellation here, I think right now I would probably triangulate the pentagon here, like this. Even though I'm trying to avoid triangles, but you know, kind of unavoidable here, I think. So I'd probably do something like this for the tessellation. Yeah, that's what I'm doing. Although that's probably just the topological part. I think for the curved surface itself, I would probably always break it down into triangles first. So that would kind of be like, not the topology of the final result, but the topology for the spline patches. So I would make spline patches out of this, and then I would put whatever tessellation on top of that and follow the shapes that these spline patches make. Yeah. So I believe that generalizes to every other shape. Let me just try a hexagon just to see if it vibes. But I'm guessing it's gonna vibe. It's a bit of a squished hexagon. Okay. Okay. Will UV unwrapping be implemented for texturing and such? Yes, I will. Probably not for the first, like, alpha version. I think I'm going to do testing there without the UV editor, so that's going to come later. But for 1.0, I'm definitely going to have UV editing. UV editing is actually one of the things I'm looking forward to the most of, of this whole application, because I personally love UV mapping, and I believe there's a lot of fun stuff I can do there. Why not make this program standalone without Unity? Well, two things. One, the app itself will be standalone. It's going to be a separate application that you can use with any game engine. But if you're asking, why am I making it in Unity? It's because I have, like, I don't even remember. How many years of experience do I have in Unity? 12? 14? How old am I? I don't know. I have more than a decade of experience with Unity. I am very proficient at using Unity. I'm very comfortable using Unity. And I'm going to be, like 10 times as productive in Unity than I would be in any other situation. And also, most importantly, I'm going to enjoy doing that work. But if I were to do this in, without an engine or whatever, I would have to kind of start from scratch. And I think that would be too overwhelming. And in case you're not aware, making a 3D art application is a lot of work. And being one person working on something like this is generally kind of unhinged. And so I need to be very careful with how much work I take on, especially because I like the problem-solving part, meaning I'm not importing a bunch of third-party libraries for anything. I'm not doing any third-party, geometry kernels. There's no third-party, I don't know. I'm avoiding a lot of third-party stuff because I genuinely enjoy the problem-solving part, which means that I'm not going to be the most efficient, and it's going to take a while to do this. Should I use AI as a beginner when coding a game? No. You should not. A really big problem with AI is that you don't know what's going wrong when something goes wrong, but it will look like the AI is confidently right about things that it's not correct on. If you have any kind of domain knowledge expertise, and you then try to make use of the AI, you realize just how much the AI can get wrong. But if you don't have domain expertise, then you can't tell if it's lying to you or if it's actually correct. It's going to be correct with very trivial, simple things, but as soon as it gets more complicated, it's going to confidently be wrong. And if you're a beginner, you're probably going to trust it too much. And so it would be much better to find, actual human written resources and learn from there and learning from experimentation. Sorry, I'm just catching up on chat. Oh yeah, someone asked about why I prefer quads rather than triangles. I talked about that earlier. It's for edge flow, yeah. Maya is fun for UV mapping? Yes. I came from Maya, and Maya is very good for that. My mind is incapable of processing. You're using an editor inside an editor. It is a little bit wonky when you're I don't know, sometimes it's easy to forget that that this is not the Unity scene view, but I have the same controls as a Unity's scene view, right? so sometimes I forget if I'm in the scene view, this is a Unity's scene view, or if I'm in my own scene view inside of the game, which has a scene view, right? And before you drop Unity, to have it run without any libraries whatsoever? I don't think I will. Is there something preventing you from doing a Bezier pentagon, or some complications from just recursively evaluating the cubic Bezier sum? So that could just be a lack of knowledge, but I'm not aware of a cubic Bezier pentagon. I could be wrong, but like the generalizing to n-gons on those corners is a relatively non-trivial problem where there's well-defined solutions for you know, 4 corners for 4 corners and 3 corners, but beyond that there's no longer one system of doing that. Even just barycentric coordinates have multiple different standards as soon as you go beyond 3 corners, right? For 4 corners, you pretty much always have a bilinear like breakdown. You do like u and v separately, but for 5, there's no natural parameterization there. So there's a ton of different methods, and it's kind of complicated. And I don't know if you can make like a pentagon Bezier. I haven't found much info on that. But I also didn't search for specifically pentagonal Beziers. Excuse me. I could be misunderstanding, but one of the things I always disliked about Maya is how it places the burden of keeping edge loops, etc. in check on the artist, favoring quads. It's basically the reason why so many artists incorrectly think quads are somehow important to preserve, resulting in less optimized meshes. I'm trying to remember if Maya had any enforcement on that. I mean, Maya did have a few tools where it like defaulted to quads, where you could have triangles. Like there's like an insert face tool in Maya that it's like easier to add quads than triangles there. But I don't remember any case where Maya would like force you to quadrangulate something, unless you like manually use the quadrangulation tool. Yeah. People talking about the dreaded Vulcan triangle. Kind of wish YouTube had more chat features. Cause I wanted to make. Do you want to be a moderator, Marco? I wanted to put like a VIP icon on you, but there's no VIP icon system, so I could make you a moderator instead. That way you're gonna look important in chat, and it's gonna be easier for me to see your messages. Quadrangulate is such a good word. I know, I love it. It's kind of weird, but I love it. But yeah, the quadrangulate feature is, in Maya, is like, if you have a triangulated mesh, it's going to attempt to turn it into quads to as large of an extent as possible. So it's kind of like a weird fallback. If you're like importing a triangulated mesh and you lost the original one that had the quads intact or something. Don't worry about asking questions that have already been asked or asking multiple times, because I have a tendency to miss questions because there's a lot of messages. So your ego's already too inflated. Well, I'm gonna make you a moderator anyway. There you go. Okay. Do you look even more inflated and cool now? I think it makes your username look different or something. I forget exactly what it does. Are you planning on a scripting API? Yes. So it's effectively going to look very similar to, you know, when you make mods for Unity games. So plugins is basically going to be that, where you're going to be able to make like C# plugins for half-edge. That's planned. I'm not 100% sure if I planned it for 1.0. I might do it for 1.0, but I haven't decided yet. I think it would be good to have for 1.0, but we'll see. But yeah, I do want to have it. It's apparently pretty easy to implement, so... are you going to use addressables? I have never used addressables, because I haven't worked on mobile games, I was going to say. But, I don't know, maybe? I don't even know the trade-offs of using addressables versus not. I've like never used that system, so. Okay. Oh yeah, I was going to talk about a thing ages ago that we've probably forgotten that I was going to talk about. So what were we talking about? Oh, we were talking about quads versus triangles. Okay. So if I, let's see, so if I, let's ignore that. Let's instead bevel all of these. Oh, the corner boundary recast failed. Interesting. Okay. Yeah, that was the error I got last stream. That we should probably look into that today. I asked if I'm right thinking that Topological does not need spatial context, angles and positions, but only what is attached nearby. Am I right? Yes, it is only based on attachment. Attachment, yeah. That's the topology part. Okay, now it works. Cool. Oh yeah, so speaking of quads, actually, can I do this on more edges than that? Can I just like do all of these? Would this work? It does work. Okay. Okay, so there's a bunch of debug information here. So pretend the debug information is not there because it's going to be kind of messy. But so if you consider an edge loop here, because I'm trying to use quads as much as possible here, I can select edge loops that just wander through bevels with no problem. So they kind of just like, you kind of have this like nice continuation of all of these faces. Yeah, so this is kind of the like, this is the edge flow that you get. So usually when artists talk about edge flow, it's about how nicely arranged are your quads so that you can do selections like this. Oh, hold on. Cats are happening. I'll be right back. Excuse me? Excuse me? No violence. Yeah. Are you gonna add layers? Which one? Which type of layer are you talking about? Because there's multiple different interpretations of that, I think. Can't believe how ridiculously hard Silksong looks. Thank you for your service. Silksong is very difficult. I feel like I have so many opinions about Silksong. I was considering doing a second playthrough on stream. My first playthrough I didn't stream because I wanted to experience it on my own. And I'm considering doing a second playthrough of Silksong and kind of like going through the game and writing down my thoughts and also trying to figure out whether my intuitions I had the first time carry over to a second playthrough. When it comes to, especially when it comes to stuff like difficulty. Now that I have like more experience with the game. What's your native language? Swedish. Did you 100% the game? Yes. But I still haven't gotten Lost Lace. I'm on the Lost Lace battle, so... and that's a difficult fight. So I haven't done Lost Lace, so I haven't seen the true ending, but I'm at the true ending, at the very least. You meant layers, like some modifications that are only on one layer, so I can't modify other parts of the model. So I think this is a really, really tricky problem. Because this gets into the whole problem of like how should a non-destructive workflow function? There's like, you can have layers, you can have modifier stacks, you can have a node-based system. Like, I haven't decided what route to go with these things. And so right now I don't have any layers. There's no like non-destructive operations right now, let alone layers. Is the way you do bevels the same as in other modeling tools? No idea. And yes, I do hide the Windows taskbar in Half-Edge. It mostly matters for like when I make a build, but can you speak about other courses you give on this topic out there? I don't have a course really on this topic. I have an old course for procedural geometry, which kind of gets into some of these details, but just generating a single mesh real time for a game is a little bit different than making a 3D modeling tool, because the data structures you use are entirely different. Because in a modeling tool, your data structures are designed for manipulation rather than being designed for rendering. And so the way you do those two things is generally kind of different. But I do have a tutorial or like a little course on procedural meshes in Unity. Okay. Polyflow and direction. Oh, polyflow stuff. I would probably search for, if you want to find guides on that, this is something that character artists especially tend to care a lot about. So I feel like if you search for any tutorials on edge flow, you're probably gonna find something from like an artist perspective, since that's more of less of a technical thing and more of a useful workflow for artists. Will there be an option to run Half-Edge in editor like you're doing right now and like Pro Builder? No. I did try to have some kind of aspiration to do this, but it got really annoying trying to make the code base work in both cases, so I ended up just doing a standalone thing. Maybe in the future I'm gonna do like an in-editor version, but honestly, I don't like the fact that most of my plugins in the past are all tied to Unity. I really want Half-Edge to be standalone so that anyone can use it regardless of engine. Obviously, the downside is that you no longer get the benefits of having it in editor, but in editor is kind of inherently per engine, right? But I think I might do some stuff where I might do some stuff that's like live editing or live linking, where you would have your Unity project open and Half-Edge open at the same time, and then the changes you make in Half-Edge gets automatically transferred to Unity and updates in real time. So like when you drag vertices in Half-Edge, you would see it also update in Unity. So I've considered doing live link stuff, which would be not exactly like working in the scene view, but almost, you know? How do you even do that? Well, you would set up a link between the two applications, probably using some network protocol or something. And then you would have a plugin in Unity itself that is basically the receiver of that data, and then it updates the meshes based on the data that it receives. So you just send data between the applications. Or maybe you can make it even more low level than that, but I don't know if you can like share memory easily. I think that's kind of tricky. So you might have to send it, but I think Unity would just auto-detect asset file changes. Well, yes, but I think this would kind of have to circumvent the import process because the mesh importer is going to stall Unity, so there wouldn't be real time, right? So you don't want to get a loading bar, or you don't want Unity to stall. So it would have to be like updating the real-time representation of the model rather than the asset itself. And the asset would be like a separate thing. Oh, so... Okay, I need to do some more cat management. And I recently learned that I should probably click the Insert Add button whenever I leave the computer for a few seconds. I have to... the cats want to go through a gate, and I have separated cats right now, so I need to manage them for a bit. Okay, I'll be right back. I'm going to click the Add button. I don't know how it works or how long the ad is, so maybe the ad is for like an hour, but hopefully not. But I will see you in a bit. It's not too bad to make a plugin which copies memory from one place into more mesh memories in Unity. No networking required. How does that work? Because I thought there were like permission stuff where like the memory of one application is generally like sandboxed away from the other. So I thought you had to use like socket stuff. Okay. There are permission stuff, you just permit it. Will I be able to permit it on Unity's end? Okay. Anyway. So, oh yeah, did you get an add? I don't know if the add button worked. You can permit it on half edges end in your plugin. Okay. But like my plugin would have to permit it for the Unity editor, right? Somehow. I don't know how that works. I'm just assuming I wouldn't be able to make Unity allow that, but maybe I could. Like I can imagine like the standalone build I make of half edge. I can imagine that would let me set permissions, but in Unity itself, maybe it does work. Yeah, I have no clue how that works. Shared memory objects creates a memory area that has permissions to be shared between programs. Read only, write only. Right. Okay. So when you say your plugin, does it have to be a native plugin, or can I just make a standard C# Unity plugin? I'm guessing it might have to be a native one if it's accessing weird memory hacks. Mr. Thor? Mister? Unity doesn't care about the current session's memory, it just cares about their internal stuff. Okay. Okay. How does that work cross-platform? Because I'm targeting desktop platforms, so Mac and Linux as well. So I don't know if there's like a general shared memory thing there. Okay, so this stream, I wanted to experiment with a very specific, not super necessary thing that I wanna, I just want to experiment with it. So this is the cap that we put on this bevel, right? Like this geometry right here. Sorry for the debug info. It's actually kind of in the way. Let me comment out the debug info. Okay, so Mac and Linux seem to use the same system, and then Windows is separate. I don't think I would use files, but like I guess I could. Like if you have an SSD, I guess it would be fast enough probably. But I imagine it's much better to use memory directly, right? Where's my debug code? This is my debug code. Let's comment that out. File part is a misnomer, it's not really a file. Right, okay. So it's more just a stream of data and then that lives in a location or something? Okay, should be a little bit more readable now. There we go. Okay. less cluttered. So the thing that I wanted to try and optimize is that I am not super happy with the distribution of this topology. I think that the shape is fine. I think the spline is okay. But I'm not a huge fan of how wobbly this looks, where like kind of look like these two are linear and it suddenly sharply turns, and then these are linear and then it sharply turns again, and then you get back to the start. I don't like how wobbly this looks, so I kind of want to try and find a better distribution of these vertices inside of this triangle. And one of the ways that I did this before kind of failed. And so I should probably find a better way of doing this. And one thing that I was considering was to do something that's a kind of optimization problem. Not a performance optimization problem, but like an optimization problem in math, where you're trying to optimize for certain properties of your of whatever data you have. So for example, one of the things that I want to do here is that I would like to optimize it so that I minimize weird internal angles here, right? Like I would probably want to have something that's a little bit softer, that's like ideally aligned with both of these tangents, and then being a little bit softer like that, right? Like this distribution immediately in this corner feels better to me. So I would want to try and find some way to distribute it a little bit better. And I haven't really tried a lot of optimization stuff before, and I do have an idea that I want to play with, so I'm gonna do that. That's what I'm gonna do this stream. Does your beveling work on concave edges? I actually haven't tried. So let me try, I guess. How would I even do that? What's a nice way to get a concave corner? I guess extrude those and then extrude these. There we go. So like this. Oh, it might actually fail this corner right now, so I'm gonna delete these edges. Because I haven't handled that case yet. Same thing with these. Mr. Thor. Hello. Yeah, I love you too. Yeah. Yeah, come on, Thor. Hop on up. Come on. Come on, Thor. Okay, we're gonna click the bevel button and let's see if it explodes. It did not explode. It, in fact, just worked flawlessly. Hell yeah. Hell yeah. I didn't even test this case until now. Neat. I appreciate this. Just ignore this part. This part is okay. Just don't look at this corner right here. Hey. Yeah. Well. Yeah. Mr. Bistro. Okay. Mr. Thor. Okay, I'm gonna see if I can give Thor some attention. Wow. Wow. Hey, buddy. Hello, buddy. Yeah, come sit in my lap for a bit. I know you want attention. Hey, buddy. Hello. want the microphone? Here you go. You can talk to chat in the microphone. He's not purring this time. Hello, Toast. Hey. Toast. Hey. Hey, buddy. It's focusing my face. There we go. Hey, Toast. Tut tut. Tut tut tut. Bloop, bloop, bloop. Wobble. 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 Apple. Zoop, zoop, zoop. Bloop, bloop, bloop. Zoop, bloop, bloop. Whoop, whoop, whoop. Wah. Apple. Whoop, bloop. Bloop. Whoop, whoop, whoop. Whoop, whoop, whoop. Hey, Toast. Dum dum. Is Toast a Siamese? Nope, he is a ragdoll. Okay. I'm so happy this worked. Okay, so mesh optimization. I wanted to optimize for certain properties inside of the topology that I generate inside of these triangles. I set up a test scene for that. Is this it? Yeah, this is the one. So basically there's different, well, there's an infinite number of ways you can generate coordinates inside of a triangle. And so right now I have 3 different methods of generating coordinates. So one of them is this one. This is the one that I call the naive coordinates. This is kind of the default way to do it, where you kind of just like, you just naively take your barycentric coordinates and you do what seems kind of right. It's the easiest one to do. That's why I just call it the naive version. You might be able to see that there's these little colored dots inside of them. And that's because I started setting up systems for measuring certain properties and then also determining whether they are close to or far away from the ideal. And specifically if they're undershooting or overshooting. So for example, in this one, the colors of the dots inside of each face here represents how close are they to the perfect area, like the area of each face here. And the perfect area is defined as the area of the triangle divided by the number of faces in the triangle. So like, if I could make it so that all of these faces have the same area, that would be considered perfect. And in which case these wouldn't be blue or red, they would just be gray, all of them. That's the way that I've been. Thor! Hey, Mr. Zoomies, what's up? Is that even possible? So probably. I don't know what the mathematical theory is of when it is or isn't possible. I'm not sure. But in this case, I do know that it actually is possible because I have a different method that I call projected. And if I reset the vertex positions to arrange them in the projected arrangement, this one this one actually seems to already be optimized for area, which was very surprising to me because this was not what I designed this algorithm for, but like, because the projected variant is basically taking the 4-dimensional barycentric coordinates and then projecting them into the 3D barycentric coordinates, and that's when you get this pattern. And I didn't think this would actually give you equal area, but this is equal area to like 4 decimal places. I remember printing the delta for these, and it is stupidly close. I just thought, oh yeah, here. No, it's not 4 decimal places. It's 6 decimal places, and then it's off by 0.00000001. Which might not even be off. It might actually just be like a floating point difference, which is kind of wild. So I'm gonna guess that this is actually, like, mathematically, this might actually be equal area already, which is kind of funny and kind of interesting that this is equal area. I really didn't expect that. And while I was writing the code to draw these little dots inside, to do this coloring, I was using this pattern, and I was like, why are the colors not showing up? Why? Why is my code not working? Like, I feel like I'm doing the correct thing. Like, why are the colors not showing up? It's all just gray. It took me so long to realize that it is actually equal area, like the whole thing. And I'm like, I feel like that's impossible. Why? Anyway, so that's kind of funny. But this is the pattern that I'm already using, right? Like, this is the pattern I'm using in the, well, in half edge, right? Pretend this looks good. I can't, oh my god, I have to fix the projection stuff. But like, that's the pattern I'm already using now. Oh yeah, my selection stuff is a little broken right now. Come on, come on. Okay, well, this path right here. But I don't like the way this is wobbly, or like if you look at this one, I really don't like the way that it like sharply turns at a specific vertex here. I want to try to make them smoother. And so clearly area is not the heuristic we should use, because I clearly care about other things than just area. And I think the next thing to look into is the internal angles of each face. Because sort of in like an ideal world, the internal angle for all of these would be 90 degrees, which is impossible. Like, I can't have 90 degrees for all of these, but I'm kind of curious what would it end up with if it tried to get as close as possible to that. So kind of optimizing for internal angles rather than area. Or optimizing for both at the same time. That's also doable. Yeah, so that's the thing I wanted to try to do next. But right now I'm not even optimizing for I haven't set up the code for this optimization. And so I'm kind of kind of excited to try this because this is kind of, it's very similar to the unfold function in Maya. If the 3 people in chat who use Maya and use the interactive unfold, that's like the most satisfying thing ever. And this is kind of like a similar type of optimization, where, you know, in Maya you would optimize for having your UVs match the world space topology, or not the topology, but the world space proportions. So this is kind of like an unfold. The code that I'm doing right now is going to be similar to the stuff that I'm going to have to do in the future for the UV unfolding. And so the way that I've set it up right now is, there we go. I should probably set this up so that I can, or no, then I'm not going to be able to do the iteration thing, or maybe, actually, yeah, let's do that. Okay. I just wanted to set this up so that it's easy for me to just switch between different settings, because right now, if I switch to the different types of topologies, I have to like manually reinitialize it. I'm going to set it up so that it's automatically doing that when I change settings. But then the problem is that if onValidate gets called every time when I do the iterations, it's gonna mess up and reset the progress after each iteration. But I'm thinking maybe I can just make a slider for the number of iterations and then I redo the iterations every time. So I don't know how many iterations we're gonna need. Let's put it at 20 or something. Solver step count, I suppose. And then in onValidate, we just reinitialize everything. Oh yeah, I can use the assignment thing. Okay, I think I can just, manually, or I think it'll automatically update now. Okay, naive, projected, hell yeah. Oh yeah, and then there was a third one. I did a third one that I called Bezier average. I really like the way that this one looks. In my mind, this is probably probably like much closer to the optimal than all the other ones. The only problem with this one is that the way that I implemented it, it kind of squeezes the edges way too much. There might be a way I can rewrite the code for this so that it doesn't do the squeezing. I think one of the problem is that like it's based off of blending between 3 different quadratic Bezier curves in the barycentric coordinate space. But I think I should be doing this in the 4-dimensional barycentric coordinate space, or use rational quadratic Beziers for this. But I don't want to do that. So I want to experiment with the mesh optimization stuff. So I'm going to do that first. Maybe I'll go back to my weird solution later. But I really like the way this one looks. The problem is that it doesn't scale to higher numbers, as you can see. It kind of goes outside. It feels like an off by 1 error. I'm sure I can just like tweak one little thing and maybe it'll work out. But Yeah, but I really like how smooth this one looks. It's very satisfying the way that these are distributed. It's just that it goes outside, so it's unusable in practice. It's iterative optimization and not a one-step. This one is one step, but the one that I want to experiment with is iterative, yeah. Okay. So, here's sort of what I'm thinking. Where's my pen? Here it is. So let's say we have a let's say we have a quad. How do we want to shape this? I don't know, it doesn't super matter, I think. Yeah, let's make a relatively extreme quad. Okay, so this one has quite a lot of distortion. Okay, so in this case, if we want to optimize for angles, this one is clearly overshooting. This internal angle is too high. This internal angle is slightly too low. Maybe we can pretend this is 90 degrees, so maybe this one is fine. And then this one seems too low as well. So let's say we have a case like this. Then for the mesh optimization, I'm thinking I'm going to iterate through the mesh, check all of the internal angles, and then based off of that, I'm going to basically add force vectors to every vertex that tries to correct for the deviation. So for example, this one isn't going to do anything because it's already 90 degrees, right? But because this angle is slightly too small, it would need to try to expand this, right? So basically turning these edges outwards. And so in my mind, that would add a force that's perpendicular to this edge to this vertex. Let's just do that in yellow or something. So this is going to be like a corrective force that this vertex is exerting on this vertex. And similarly, it's going to exert the same force on this one. So that's what this one is going to do. Alternatively, I could do something like applying a force to itself inwards. Maybe that could work too. I'm not sure what's best, but I think this would allow me to kind of calculate the required force in order to reach 90 degrees, right? So then I can kind of scale it based off of the required amount. That way it's going to approach the correct one rather than accidentally overshooting it. And then for this one, the angle is too high. So this one is going to apply forces to this vertex, or its neighboring vertex, to try and close it to approach 90 degrees. So this is also perpendicular to this edge right here, this yellow force. Same thing here, applying a force to try and shrink this angle. And then this one is too small, so this one is also going to apply a force in this direction. And on this one, it's going to apply a force in this direction. So once I've iterated through all of the vertices in the mesh, I'm basically going to just sum up all of the forces and then move the vertices based off of those forces, multiplied by some factor to like slow it down, to not like make it aggressively step too far or like accidentally overshooting. So yeah, that's what I'm thinking. And then some points are going to have constraints. So for example, if you consider let's see, I don't know how many vertices I'm going to need for this. I don't know, 5 is probably enough. Wait. Okay, pretend this is equilateral. This is a perfect triangle. I don't even know if I got this right. Okay. What? Oh wait, I'm doing quads. These aren't quads. Hold on. Oh Jesus, wrong tool. Oh yeah, because it's right. This is the tessellation we're doing, and then there's one in the middle, I believe. Yeah, this is the actual topology. There we go. Because we kind of have this quad ribbon around the edges. Okay, and then we have quads like that. Okay. So I'm thinking some of these points are going to be constrained. So for example, this point can never move at all because like these vertices are just locked in place. Like there's no more optimal place to put these, right? So they're just gonna always like live there. And it's actually the same thing for any along the edges. I don't think there is, maybe there is, but I don't think there's any reason to let you have a different distribution along the edge because they're already perfectly equally distributed. Maybe I can experiment with that, but so these shouldn't change at all, right? So the boundary vertices have to remain fixed. And there are some of these that are kind of partially fixed. Oh yeah, the center one, for example, is fully fixed as well, because the center one is in the perfect location. There's no better place for this to be. You could probably sort of, like, you can sort of make an argument that it maybe you should let it move in one direction, because like, if you consider like all the vertices here, they're not equally distributed, right? Like the distance here, like this distance is bigger than this distance. So maybe you could have an argument to like more equally distribute them in here. So like you would move these up a little bit. But the problem is that you can make the same argument across all 3 axes. And so all of these would cancel out. And so there is no more optimal place than the center. And moreover, I think the same applies for all of them in the center in general. So, come on, there we go. So like this vertex right here, actually let's include the edges. So these are like, these should also be locked, but not entirely. So these should be partially locked. So the idea is that these should be allowed to move along this line right here. So it should allow, you know, movement along this axis. They're kind of axis locked in a way. Same thing goes for these. So they're also axis locked. Same thing goes for these. They're also axis locked. And I believe the same goes for these vertices right here. I keep forgetting which tool I have. So these vertices, in a sense, they're not connected here, but these vertices are also axis locked. You don't want these to go sideways, because then you're going to break the symmetry of the triangle. So they are also axis locked along, you know, the same as this one and this one and this one. Yeah. I think that's the vibe. Maybe I should allow these to also be axis constrained, but Okay, sorry, I haven't been reading chat like at all, so I don't know if I missed like every question in the universe. Or figuring out the geometry of a bevel on a corner? Yes. Pretty much. Specifically, I'm trying to like distribute the vertices in a nicer way. Maybe shouldn't apply force to already 90-degree angles. Well, I'm not sure, because that is like a special case and they're almost never going to be exactly 90. So it's a matter of like, because if the surrounding vertices are allowed to move, it's no longer going to have 90 degrees internal angles anyway. And so as long as they all approach 90 degrees, I think it's fine, because it's going to be iterative, right? Wouldn't doing this the other way be more efficient? The other way in what way? Which other way? I'm guessing there's kind of multiple different ways of doing this. What if n, the number of cuts, is not an odd number? There would be no vertices at the center. So there are still vertices that are aligned on at least one axis. So here's an odd number, right? You still have some of these aligned with the center lines, right? So like these vertices are still center aligned. It's just you wouldn't have a row of vertices here as well. But I think that the same rules apply there. And yes, a single triangle in the middle. That's the way it's designed right now. I think you're overcomplicating this. Potentially, but that's okay. If you make the edges springs, I suspect you would get the same result with easier math. But that would require knowing that's better for optimizing for edge length, right? And I don't have a good heuristic for what the optimal edge length should be. And so I'm not entirely sure what I should optimize for edge length. For area, there's like a very, very straightforward way of just taking the full area divided by the number of faces, but I don't know if there's an equivalent for edges where there's like a definitive correct edge length. I'm not sure. I guess maybe it could be like I'm optimizing for like this edge length or something, but then pretty much all of the internal edges are going to struggle to reach that, I think. Yeah. A too large angle will be opposite a too small angle, so it would always move a node towards a small angle with a damping factor if iteratively. Yeah, that's true. Yeah, I suppose there's a lot of different ways to implement this. You could make the target edge length based on the dot product of the two angles. Oh, as in like it's still based off of the, oh, it's like it's still based off of the angular one, but I apply the constraints through edge lengths or something. I guess I could do that. But I think I want to try the vertex force idea first. Because I'm curious to see what happens. And I'm okay if it fails. That is fine. So I think the way I'm going to do this is do this algorithm where I'm adding forces to all the vertices, and then based off of the constraints, I'm either going to nullify the forces or project them to a specific axis, because all of the vertices in this one, they are constrained to something, either fully constrained or constrained to an axis. If I had a higher tessellation, there would be some completely unconstrained points that would not be constrained by anything. So that's going to be there for any like n above 5, but 5 and below are going to be pretty constrained. But yeah, I wonder if I should do some of this on a per face basis instead of thinking of it as a per vertex iteration. How would I do that? Would that be something like, let's see, would that be something like getting the average position, and then based off of that, I could sort of get some kind of skewness factor or something, and then, because then I can check the internal angles from each face. I guess it's just kind of the same thing. It's just like I do it per face instead of per vertex. It's actually easier to iterate the faces now that I think of it, so I should probably do that. Okay. Oh yeah. Ooh, I think that's actually a pretty good heuristic here. Okay, so how about although what basis would I pick for that? How would I pick a canonical orthonormal basis that's like optimally close to whatever sort of right angles I have in this drawing? Because I have this like intuition that I want to pick like a canonical basis for this. And then after I have that, I would use that to project the vertices into an arrangement that would force like 90 degrees internal angles. And then once I sort of have, I guess it would be square, or rectangular at least. And then once I have that, I would scale the whole thing, like this whole face, the imagined face. I would scale it up to have the same area as the original. And then the vector from the previous vertex to the target vertex, that's going to be the new force. That's going to be the force that it's applying to that vertex, is kind of what I'm thinking. But I'm not 100% sure how to find this basis. Because I don't, well, I guess I could. I don't want to just randomly pick a vertex and do a basis from that, or randomly pick an edge, because I want to try to make this, I would want it to be invariant of which edge you would pick there. So it would sort of have to be based on all edges. Why does your webcam have a high production value? Because I have a high production value as a human being. I guess I don't have to do the face-centric one right now. I can try my original idea first. Yeah, because technically the basis doesn't super matter. The only reason I would consider that is that I can normalize the face such that I match the area, because right now I'm kind of like just ignoring it entirely, which maybe that's okay. Okay, let's try this force idea first. See how it works. Could you just have a universal basis then? I could, but I want it to be symmetric from the perspective of the barycentric coordinates, and that would have a bias toward a certain direction, and I don't like that. So I want to try to avoid stuff like that. But okay, I think we got a good start. So let's think a little. Well, how do we? Okay, so let's say we are on a face. Okay, I'm gonna use my mesh standard colors here, and we're looking at this internal angle. Okay, and then we got the half edges. So I guess this would be the half edge that we are caring about. And then, given this half edge, we know that there's an optimal 90-degree target. So we would like for this corner to look like this. Kind of this vertical line here. And this vertex has some location. So is the goal then to just project this onto this line, and then the force vector is going to be this vector? No, wait, hold on. No, that is the force vector. That projection is the force. Or no, I guess... No, I guess I can just reverse it. Like, I put that force on itself, rather. That might be easier, actually. Or... It's probably going to result in the same thing, actually. Or I could do the average. Or like both, right? Like, I do half of it on one and half of it on the other one. For some reason, that feels more stable in my mind. But I don't know if I'm correct on that. Like I would instead try to align it to the center, so that I would apply two forces. A force here and a force here. I would guess that it doesn't matter. I think once you add up all the forces, I think it's going to be the same thing, because there's so much symmetry. But yeah, if I were to pick only one, I think applying the force to itself is probably more... it's nicer, because then it's kind of like locked into the responsibility of locally, instead of like stretching over to a bunch of other data. Yeah, I'm guessing it would normalize regardless of how many other things I have. So let's just do that one then. Let's just move itself. Or not move, add force. So then it would be the force going here. Like so. Let's call it F. Wow, that way you know it's a force. Okay. Although... Wait. The advantage of adding the force to the neighbors is because there's more than one neighbor, right? Or I guess it would be like an iteration regardless. Either I iterate the neighbors, or like either I iterate the neighbors and add force to all the neighbors, or I iterate the neighbors and add the summed forces to self, right? Because there could be another edge here. Oh, weird. That's the wrong color. Or wait, no, that would be part of a separate iteration, actually. So that's fine. What would that be? We would have a... the half edge would be here. And if it's adding forces to itself, in order to align with the previous, right, there would be a vertex here. Right. Okay, so I think yeah, it would basically be a force like this, I think. Am I feel like I'm mixing things up, because I feel like too many things are aligned here. Hold on. Let me just unalign these vertices so that I can think clearly. It was a bit of a too perfect 90-degree triangle there. Oh shit, it's still aligned. It's kind of aligned in a different way now. How about here? Okay. So we got our half edge. And applying force to itself, it's comparing to the previous half edge projected to the line that is itself. So that would be, this would be the projection. And then it would basically project to this specific point here. And then I guess that's the... Yeah, that's basically the force vector. Because the force vector is always aligned with the root half edge we're applying the force from, I think. So yeah, this is correct, I think. So we would get the force vector along itself like that. That would be added to this vertex. Okay. Does this make sense? Let's zoom out a little for the greater context. So we have an angle that's too high here. It would try to move the vertex in that direction to decrease that, which makes sense. We have an angle here that's way too narrow, and it would try to widen it by moving the vertex down here, which would widen it to 90 degrees. That makes sense. And the sum of these two vectors, like doing the sum, would be like this, like that, right? So this is F0, this is F1, and this is the sum of all the forces. Okay, does this movement satisfy both? I feel like this movement kind of mostly satisfies this constraint, but not really this constraint. It's kind of shifting parallel to it. But maybe that's okay. Also, I think might have painted this a little bit wrong, because it's more like the... Let's see. Let's get a slightly more accurate reading of this. Or wait, no. It's adding those two, which would be the parallelogram. Right, I'm stupid. I know how vectors work. Right, it would be like that, I think. Is that actually getting that angle any closer? I feel like that's kind of a wash on this side. But I guess it's not, it's also not complete, because we would have, because we're not taking these angles into account. So maybe if we do, it would be fine. Maybe immediately moving the vertex after calculating each force. I think that would introduce too many jiggles and potential situations for overshooting. Yeah, it might actually be okay once we iterate everything. Okay, I'm gonna try this method. We're gonna see if this works. Now for the easy part. I think this is the easy part. I think we figured out the difficult part. And then once we actually try this, it's like gonna explode or something. Okay, so we have a solver step count, currently at 0. So I guess, let's see. Yeah, we're gonna make a separate function that's called solve, I guess. And then we make a for loop for step count. And in here we do the iterations. And we want to do the solving here. Oops. Okay. How do we do this? We want to... Oh yeah, I kind of forgot about the constraints. Because some of these vertices are fixed entirely. Is that okay? Because I think that might make a difference in terms of vibes when it comes to like, should it apply forces to itself or its neighbors? Because if it's only applying forces to itself, the vertices that are locked in place are not going to be able to affect anything from their own perspective. But neighboring vertices would be able to read those, I suppose. I feel like this would probably like work out the same way regardless of whether we add forces to neighbors or not. Okay, so this is basically going to be in 2 steps, I think. It's gonna be like a calculate forces step and then a apply forces. And apply forces, I suppose we probably need a force multiplier down the line for like how strongly it should apply that force. Because there's a risk stuff is going to overshoot and just explode into infinity, which is usually not good. So we want a force multiplier. I'm going to start at 1 just to see how that would work out. Okay. So I guess we can probably just debug the forces in and of themselves, which would actually be kind of interesting. Yeah, let's do that. We could also, I kind of want to visualize the internal angles, even though I don't need to, but it would look kind of pretty. It would be a good exercise to make sure that I got valid input data as well. Okay, do I have an internal angle? Let's see. No, mesh.internal or angle. Really? I feel like I should have an internal angle calculation. Do I not? Okay. Or wait, is it in like the half edge? Well, I do the miter vectors. Try degree? No, it's not going to be called that. Because I'm not using a library. This is my own code. Okay. Or wait, no, I know that I use internal angles. Oh, it might actually be in the cached buffer. Tangent angle, that's what I call this one. Yeah, okay. But this is like the result of a weighted version of it. Okay, but I can use the same function, I suppose. Also, this doesn't have to be like optimized, so I don't need to use like cached data or whatever. I can just compute it live. All right, let's just make a function like that. So I guess that would be float get internal angle. I guess I could use the cosine of the angle rather than the actual angle, which would probably be both more useful and more performant, but it's a little bit harder to intuit. No, I'll just use angles because it's going to be much easier to reason about it, and then I can like change it later if I need to. So we want the internal angle at a specific half edge. It's probably better to get the internal angle of the next one for optimization reasons, but we don't need to optimize. Why am I thinking about optimization? I need to stop my optimization brain. Okay, get internal angle at a specific half edge. So then we need the we have the geomath tangent angle. Pre-normalized, they are not, I think. Make it exist first, exactly. Okay, it's just the direction and the normal. I can't believe I don't have a function for this in my mesh data code. I should just put it there. Mesh data spatial. Okay, angle. Oh wait, I have the, oh no wait, that's the dihedral angle. I just feel like I have to have had like an internal angle. Although I've also had a few situations where like I used to have a thing and then I moved it or deleted it because I replaced it with something and then I just don't have it anymore. Okay, whatever. I'll just just create a new function. And I guess I should call it calculate to make sure that this is actually kind of expensive. It's not grabbing cached data. Okay. Maybe the normalized edge dot product would also be an okay visualizer. Yeah. Yeah, it's also like the dot product. If I'm not using normalized data for that, then I am actually making a projection, and that's the useful data for calculating the force. Like I don't actually need angles at all to like calculate this, and so the angles right now is probably just because it's easier to like think about them, but I don't need angles. Right, okay, face normal. We want the face normal of, we need to know the face. Half edge, face of the half edge. Then we get the face normal. And then tangent angle, direction A and direction B. I think tangent angle is meant, I think it's just called that because it's like two consecutive directions rather than two opposite directions. I think. Because I think it's made specifically for... no one needs angles, they're just made to rotate us from big math, exactly. Yeah, that's like this whole function is like you would sort of assume the thing that I use this for would require angles, but it actually doesn't. I just need the sine of the angle and the cosine of the angle. I don't need the actual angle. And there are so many cases in math where you just don't need angles. You're just fine using the projections. And so there's so many cases where you like round trip like trig functions and angles, even though you don't have to. Which is kind of funny. But that's also why, like, transformation matrices and quaternions, that's why those are fast. Because you don't round trip angles, unlike like Euler angles. For Euler angles, you do need to round trip and do like trigonometry and then back to actually apply it to something. Okay, tangent angle, we need directions. Cool. So we need the next half edge, which is next get half edge next of that one. And then I believe we just need to do direction, half edge direction. I appreciate the comment that I wrote on this one. Oh my god. I don't know if you can tell what it says here, but I wrote this in the summary because this would be exactly the question that I would ask myself in case I forgot how I wrote this function. So it just says, yes, it's normalized, that's what I wanted to know. Okay, so the half edge, and then the next half edge, and then the face normal. Cool. This is now our not very optimized way to get the internal angle. Okay, nice. We are now ready to start visualizing that, I believe. Did I have a list of like ideal internal angles? Probably not. Okay. Optimizing comes later? Yeah. Because like I'm gonna be calculating the face normal completely unnecessarily because this is flat. Like I know the face normal and it's the same for all of these. The face normal is just the z-axis. How would you feel about calling it calc-normalized half-edge direction? In my terminology that I use, direction is always normalized. If it's not called direction, then it might not be normalized. So usually I would call it like vector or something, or delta if it's not normalized. But if it's normalized, it's always called direction. But sometimes I'm inconsistent because I'm human, and so I guess that's why I wrote that comment, because I wanted to make sure that like I don't have to second guess my past decisions. Okay, draw shapes. I just want to draw the little angle pies, because that's going to be kind of cute, I think. And then color code them. Basically the way that I did here. So how do we do this? I want to calculate the internal angles. I'm starting to think about optimization again. I really don't have to optimize. Stop. Stop thinking about optimization. Okay, what's the ideal internal angle? Is tau over 4. For now. Internal or angle ideal. There we go. Because I don't think I have any other angles. It's always going to be internal angles. Okay, and then we want to iterate through the faces, I suppose. Or wait, I can just make it for each. Mesh dot faces. And then for each, mesh dot half edges of face. This could probably be combined into a single link query. What would that be? Like select many, I think. Select many, and then plop this one in there. And then this would be the half edge. Yeah, that would be it, I think. Do you use any AI engine in your workflow? Nope. Because I am not a fan of AI, and it is I am morally opposed to AI, and the few moments that I actually tried it, it was gaslighting me, and it basically made it so that I made less progress. It reduced the amount of progress I made because it added confusion. I don't know. I found that like ChatGPT can be okay when you use it as a search engine for things you can verify the answer to. Like if I forgot a word, then I can use ChatGPT to like ask it with extreme precision in ways that you can't do in regular search engines. That's like the biggest use case for ChatGPT in my mind. Or sort of like you can use it to like find terminology that you might not be familiar with in areas you're not familiar with to get search terms to then do research on your own. Like that kind of stuff. That's sort of what I think it's useful for, but to ask it to legitimately help with specific problems, especially if you don't have any domain knowledge, has been, every time I've tried to do that, it's been a really, really frustrating and annoying experience, and I just don't find it useful. Is math your class? Yes. The maths is my class. Unity has a similar one called math. This is Unity's. Mine is the one that has an S. Okay. All right, so I have the ideal angle, we have our half edge, and we want to get the internal angle. So internal angle, there we go, of the half edge. And then we want to get the difference with the ideal angle. Yeah, the delta. So what direction do we want to do this in? This would be the deviation from the ideal. Yeah, that's what we want to do. And then I guess we just need some colors, which is basically going to be the same thing as here. I should really make a triple lerp function because I'm going to use it twice now. Public color or static color. Try lerp clamped, or no, I can clamp separately. Then we have color A, color B, color C, float T. I think my writer theme is there's like a Visual Studio Dark, but I've also modified it a little bit. But I think Visual Studio Dark was my starting point. And then basically we want to grab this. This is pretty much the same thing. Would a deca lerp be called derp? I am happy to report that I have actually found use cases for a harmonic lerp, which if you shorten it, it would be herp. So that's something to be delighted over, I think. Okay, I think this is sort of it, except like I need to make it a little bit better. Okay, this is it. Let's see, T less than that. Oh wait, I need to replace the actual colors. It's probably good to make use of my parameters. Like harmonic series, I presume? No, more like inverse, like a 1 over x type harmonic. So harmonic lerp, you would use that for blending. Oh god, I forget which one it is. I think it's if you want to get the if you want to interpolate between frequencies, I think the harmonic lerp linearizes the change in wavelength. I think, I forgot exactly, but it's something along those lines, because like if you consider the frequency, the inverse would be the wavelength, and vice versa. And so you could use the harmonic lerp to blend frequency data, either frequency or wavelength one, but I think frequency, because wavelength is a one-dimensional thing. So basically you could use that to interpolate frequencies and have linearly changing wavelength in that interpolation, basically. And so the interpolation in frequency would be nonlinear, but the resulting wavelength change would be linear. So that would be the harmonic lerp. Herp, exactly. Exactly. Okay, am I done with my very simple function? I think this is it. You know what? You rarely want to extrapolate colors anyway, so I'm just gonna make this clamped. Okay, try lerp clamped. Okay, so draw color equals, oh yeah, I can replace this one as well. It would be draw color equals try lerp clamped from red to gray to blue T. Okay, I believe that's it. And then we do the same thing here. But we need a T value for that. So what is the angular? I guess we can make a variable for the angular range. Deviation range is a bad name for this. This is the area deviation range. What resource do you use to learn all of this? Oh god, that's a very broad question. I mean, most of the stuff for half-edge, I'm not using resources. I have been looking up like math papers on specific stuff like spline patches, for example. That's something I did recently. But for most of this, I haven't looked much up because I really enjoy problem solving. Can't find anything harmonic lerp online. That's because nobody calls it that and nobody uses it, and it's not a thing. Like I'm making it up. But it's also not bullshit, because I have done those functions. I just haven't yapped about it online yet. I believe it's in my Desmos somewhere. I have actually considered making a video about these alternative lerp functions, because I do think it's a really interesting and weird topic. Where did I put it? What? Lerp? Yeah, this one. So I was sort of working out the grand unified theory of lerp, sort of. Oh god, I forget. I probably have some like stray notes that are unrelated to all of this here. But I have herp right here. Let's see if I can just hide some of these. Is this the herp function? No, it is not. This is something else. Go away. We were gonna look at the herp function. Okay. Where's my herp? There we go. So this is the harmonic. Harmonic interpolation. Right now the graph is not square though. Let's do that first. Let's reduce this one a little bit because this one is kind of unhinged right now. Okay. Harmonic interpolation. That's what we got here. And you can see that it sort of follows a 1 over x curve, right? That's harmonic interpolation. So if we were to like interpolate between, so like the y coordinate of each of these is the value that we input into the herp function, and then the line is the output, and then x is the t value along the lerp. And so if let's see, if I set this at, oh yeah, I talked about this a little bit on Blue Sky, I think. I think I asked people, like, what's the average frame rate between 30 FPS and 120 FPS? I think I asked something like that. And this kind of relates to the harmonic lerp. So the y-axis, if the y-axis represents frame rates, this would land on 48 frames per second, would be halfway between 30 and 120, according to the harmonic lerp. Because halfway is kind of like, it depends on what you care about when it comes to halfway. If you use a lerp, you get like a different type of halfway, because then you get the halfway frequency, but that's not linearly changing the it's not linearly changing the wavelength, which is probably something you might care about more than the actual rate. Is this geometric mean? I forget which one is the geometric one, because there's also the thing that I call ERP, which is exponential interpolation. I forget which one of these is the actual geometric one, because yeah, harmonic mean is the same thing as oh yeah, that's true, because geometric would be the other one. Yeah, so the harmonic lerp halfway would give you the harmonic mean, with I think the geometric one would be the exponential average. I think, but I could be wrong. I don't know the formalities between those. So that's the blue line here. So according to the exponential one, halfway would be 60. Yeah, harmonically it's 48. Geometrically it's 60. And then I forget what the normal one is called. Linearly, the linear average, I guess, would be right here, which is 75. So like when you ask like, what is the like, what frame rate is halfway between 30 FPS or 120 FPS? there's kind of like different answers depending on what you care about. And I think that's kind of neat. I don't know, I find that interesting. And so, I don't know, I was just curious about this. And then there's other ways you can, like, you can also do this based off of like powers. So if I set this one to like 3 or 2, so like you could base it off of like 2 to the x as well, and then you would get a different curve on that as well. So that would be stuff like if you have a linearly changing edge of a geometric object that also scales the area, then the relationship between those two has, a power of 2 relationship, right? Or wait, 2 to the x squared? I might be talking about x squared rather than 2 to the x, because that would be exponential, right? Anyway, but yeah, so it's kind of just a way to like linearize something else while you're interpolating the original thing. But yeah, that's why you're not finding anything about it online, because nobody talks like this. Can herp extrapolate? Yes, it can. All of these can extrapolate. Anyway, what was I doing? Where was I? What were we doing? We were solving some forces. Oh yeah, no, we were not. We were drawing internal angles. The basic pattern is, yes, pretty much. Yeah, I think I even had that in that Desmos, but I closed it, so now it's too late. Okay, draw shapes. Internal angles. Right, we were gonna get the t value, but because it's... Okay, do we wanna... I guess we kind of want a linear deviation here, maybe? Or no, maybe we can... No, we can use an inverse ERP for this. I think that's okay. It's kind of like a multiplicative deviation, I think. We just need to call it something else. So we have the area deviation, and then we have the angular deviation range. What would be the maximum deviation range that we would ever care about? I guess that would be like 90 degrees, I think, deviation. So that would be tau over 4. And then, I don't know, 0 is fine. No, wait, it's not fine. Okay, probably start, or we'll just modify that later. Are you planning on doing some gradient descent as some arrow functional? No, because I think I want to try to do basically that, but like stupidly first. Okay, wait, t-value, we got the t-value. We just need to insert the angular deviation there. Although we can't do... No, it kind of has to be... Yeah, it kind of has to be inverse lerp, actually. Never mind. Okay, so then instead we would do the ideal angle minus the range, or no, wait, ideal over 2? Guess it doesn't matter. And then ideal over 2 minus deviation, I believe. Wait, what? What? Wait, am I stupid? What's going on? Is it because I have errors? Or no, wait, I closed this function. That's not good. And the deviation would be the delta we have here. Okay, and the max is actually not tau over 4, it's tau over 8. Because 45 degrees on both sides would make a 90-degree angle. Okay, so if it is undershooting, it would be red. If it's overshooting, it's blue. Okay, my intuition says that the color should be swapped. It should be blue if it's undershooting and red if it's overshooting. Red feels more like the too much colors, and we have too much internal angle. And blue feels like it's a bit cold and lacking. And so that would be the two little angles going on there. Okay. I guess oh wait, we need to actually draw it. We're not doing that. So how would we draw this? I guess we could do using draw dot matrix scope, and then we do draw dot rotate. I guess we do a mesh dot half edge direction, and then we get the can I just like cast it to a float, or I guess I can do XY, and then do I not have extension methods for that? Okay, do I have float 2 extensions? Oh, float 2 extensions. We got them. We do have float 2 extensions. Hell yeah. Angle. So we would do a10 to p dot y, p dot x. There we go. Okay, angle. Cool. We're rotating it by the angle. And then we want to draw a disk. Or no, we want to draw a pie, actually. Let's see. At the half edge direction, or half edge position. Well, I don't need both positions. What? Do I really not have a shortcut for the half edge root position? Really? Oh wait, origin. Oh yeah, I call it origin. Oh yeah, origin position of half edge. Hell yeah. Okay, there we go. Okay, and then we pass the half edge ID. Whew, okay, I was like, damn, I very much remember having a shortcut like this. You know what? We can just translate to that position immediately. We don't have to deal with some parameters in the pi function. Okay, then we have the angle. Angle start, 0. Angle end would be the internal angle, which is ang, I guess. Just ang. Then the color is already set. My intuition says we need to do negative, because I'm aligning the x-axis with the half edge itself, but we're measuring the angle backwards. So I think we need to do or start from negative angle going towards 0, I think. Yeah, okay. Well, it is drawing nothing. What are we using for our parameter? Oh wait, it's compiling. It's compiling. Oh, 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 oh. Now I'm seeing something. Okay. Well, this is very tiny. We should probably set the radius. That's the first parameter. Okay, what's the radius? I forget how big everything is. Oh yeah, wait, radius is in pixels, actually. That's really useful. So we can set the radius to 16. Okay. It is not quite right. Wait, did I get the next half edge for the internal angle? Hold on. Where's my internal angle? Wait, I just scrolled away from it. Oh, I did get the next one. I mean, I guess that's... So this is more optimized, but it's more intuitive that it gets the angle of the actual half edge. Yeah, but that's okay. That's okay. Yeah, it's just faster to get the next half edge than to get the previous half edge, because the previous half edge requires iterating around the whole face. But the next one is already encoded in the half edge itself, or encoded, saved, stored. Okay, well this is looking kind of like we're the opposite of what we want. Okay, wait, what's our deviation? I haven't set the angular deviation yet. Okay. Okay, I'm clearly missing something here. Am I setting the right parameters? Let me just make sure. Okay, let's not do negative just to see. Oh wait, I think it's actually the internal angle that's incorrect. Yeah, this is incorrect. We should swap these two. Why tau over 4 and not pi over 2? Because tau over 4 more explicitly tells us that it's a quarter of a circle. That's pretty much it. Okay. Okay. I'm not quite sure why why it's a binary. I feel like let's see, does the area... Yeah, the area one is properly interpolating. But I am getting the T value, or something about the color interpolation is not working. It's looking weirdly binary. And this shouldn't have this behavior at all, actually. Yeah, something's very wrong with the way that I get the T value. Where am I? I'm in the wrong script. Go away. Line 144 looks funky. Oh, yeah, this is incorrect. It should be plus here. Hold on. Oh, it's also funky because I don't need this part because it's already the delta, actually. This is looking more like it. Now it's looking the way I would expect. Okay. Let's see. Oh, that's the area deviation. That's not what I wanted to touch. Right. Okay, so now we can sort of control the contrast of the angular deviations here. Okay, let me also make them maybe not twice as big, actually. That's probably going to be too big. 26. That feels nice. And then I also want to put them underneath the edges. So we're gonna scoot these all the way up here. Oh yeah, I guess the ideal internal angle is not always 90 degrees. That's true. Yeah, it would be based off of the number of yeah, I guess is that called valence? I'm bad with terminology. The number of vertices in a face. But one way you can solve that is to just use even numbers. That way we don't have to deal with triangles. Why is this red? Oh, because the color is leaking, that's why. You know what? We can just draw dot scope. There we go. No more color leaking. Okay. Poor center point. It's struggling. It's looking very incorrect there. Is it only the because it can't correct that one? That would be like the, do I divide it by the number of outgoing edges, or not that I need to solve it for that point, because that point is locked in place anyway, but kind of curious. I guess it would be. Or if it's from like per face perspective, I could just use the number of, or no, I can't use the number of, no, I guess it should be, because the face wants this to be 90 degrees, but the vertex wants it to be 120. So it's kind of like it's a matter of perspective, right? It's kind of interesting how this one is like, it's solving a lot of these. It's looking really good in the angle department for most of the vertices here. That's kind of funny. That's actually super interesting, because like this pattern solves both area and angles for so many of these. That's funny. Okay, wait, what is Unity doing? Why is it showing the pop-up in the completely wrong location? And here's the naive distribution. It at least leaves these 90 degrees. My wonky one doesn't have these at 90 degrees. What's wrong with Laplacian smoothing? I don't know. Ask Laplace. Okay, interesting. There's also like a few situations here where like I think there's an argument to be made that the ideal angle for these should be that they're pointing towards the opposite vertex. rather than pointing directly outwards. Because I think in terms of edge flow, if it points towards the opposite vertex, I think that makes the bevel's tangent. And so there's like an argument to be made that these shouldn't be 90 degrees at the boundary. Question, if not flat, the sum of angles in a quad is not 36 degrees. Do I have to take this into account? Nope, because I'm only solving this in the barycentric coordinate space. And so I'm going to use the same one in the whatever situation it might be in later. So it's basically 2D coordinates that we just solve for one case. Okay. Trying to think if we should implement the... actually, let's first make it so that we're visualizing which vertices are locked to begin with. Because like there's no point in showing the angles on vertices that are completely fixed, because they can never have their angles changed. Yeah, none, well, actually, the boundary ones can, but not the corner ones and not the center one. So, let's see, how would we do that? I guess we would do something like getting the vertex ID of the half edge. Root. Get half edge origin. That's what I called it, not root. Half edge origin of half edge. And then we can use the dictionary. What did I call it? Vertex to point. So we pass in the vertex ID. Okay, this is called force point because this is kind of the data structure I have for dealing with all the force stuff we're going to do later. Okay, so if the axis lock mask is wait, I feel like the... Okay, actually, do I have a constraint? Yeah, I do. Okay. So if that is... Wait, how do I distinguish for the boundary ones? Because I'm not distinguishing between fixed on the corners. Whatever. It's okay. Let's just do continue. I just want to double check to see which ones we're skipping over. This should remove the boundaries and the center. Okay. What happens if you connect the vertices with just straight lines? You will get very bundled up faces in the center. You'll get like large faces along the boundary and then very small faces in the middle, which is usually not desirable. I guess the naive version is kind of close to that. It's just got an additional offset along the boundary, but it would look something like this, but like even more scrunched up in the middle, which is not good, I think. Don't like that. Doesn't vibe. Okay. I think we're ready to do the optimization code. I think. Probably, perhaps. Okay, hold on. I don't like this gray color. I want a darker gray. Do I have a dark gray? No. Okay, whatever. Okay, you know what? Multiply RGB by 0.5. There we go. It was too bright. Didn't like it. There we go. That's better. I kind of want to make it just look like the background color. Is that legal? Because then it's gonna just kind of fade out. But maybe that's okay. How'd you come to the idea of this tool? Also, are you a game dev or why do you know Unity? Yes, I'm a game developer. And I know Unity because I've been using it for the past 12-ish years. And yeah, that's why I do it. The reason I'm working on this project is because well, the big reason is because I want to. And the other reasons that sounds more justifiable is that I do believe that there's a space for a 3D modeling tool that is easier to learn than Blender. And not made by a shitty company like Autodesk that have kind of shitty monetization practices that are prohibitively expensive. So I'm trying to make something that's kind of like more user-friendly and easier to use, and that's made for game developers, because most 3D tools are not made for game developers. Okay. I think I'm done playing with the visualization. This looks pretty good. I think I'm satisfied. Sorry, I've been taking ages just to do this. All right, I guess we are ready to do the force visualization. Actually, why does this blue look so ugly? This is not the blue that I wanted. Where's my brand blue? There we go. Okay, come on, give me my brand colors, not this goddamn RGB blue. Nice, there we go. Those are the right colors, cool. Neat. Okay, forces. So how do we do this? Do we do a face-centric like moving itself based off of yeah, I think so, because we're gonna want to iterate through. You had the same ideas about brand colors? What do you mean? Oh, did people tell me to fix the colors? Push the vertex towards the blue angles. I guess that would be like a relatively I guess that would be like a simplified version of that, yeah. So if you have opposing blue, like this one right here, I guess you could kind of like have them counteract each other maybe, but yeah, would you ever have reds only? I guess not. The brighter blue? Yeah. Okay, I can see one problem with that so far. But this might actually be a problem in my solution too. But I feel like this is going to shrink into the center because we don't have any forces counteracting that force. Well, no, I guess I do have that because like if we look at this one would move towards the center. And then once it gets too close, it would never move in that direction again because now that angle is a red one, right? So it would actually have a reason to stop. And if all three of these angles are red, this one would be blue. So then it would move away again if it's too close. So it would actually work. Yeah. I guess that's a much simpler way of doing it. The only question then would be how far it should move. Which... Okay, let me draw. Can we use this one? No, it's too cluttered. Okay, so we would have the situation we have is sort of like some kind of kite. With a pretty steep angle. So the idea would be to move this one in this direction. And the distance I need to move is whatever would cause a 90-degree angle here, right? Sort of like here. That would be its goal, I think. Yeah. Okay. So how would we find this vector? We got a math problem. Okay. What would be an appropriate way of doing this? This feels like a if you know similar triangles, I guess this is like a super easy problem, I imagine. Because I'm pretty bad at memorizing all of those rules. Well, I'm guessing, let's see, so we got a line there. These two angles are the same. No, wait. They might not be. They are in this case, but they might not be down the line, right? Seems like you could get a closed form solution to this. This particular problem, yes, absolutely. This is probably just a projection or something. Or two. Yeah, how would I find this vertex? Actually, there's too much symmetry in this one. I feel like I need to draw a non-symmetric version. Because otherwise I might find false solutions. Okay, so what would be a non-symmetric version? That's still got a... Let's see. Okay, so that's a long one, and then maybe like a short edge here. And then those connect in some kind of weird way like this. Okay. So what would be the goal? It would be move this such that you have a 90-degree angle between these two. But this is also not a... Oh wait, actually. I think I know this. Okay, yeah, it would be... So take the line between these two, take the center point, and then that forms a circle. And any point on this circle is going to have 90 degrees between these 2 points, right? Any point here is going to be 90 degrees. And so all we need to do is just pick whatever direction we want and then just normalize it or intersect it with the circle, which is basically just a normalization and then multiply by the radius, I suppose. Okay, so then the question is, what direction do we pick? And my intuition says that, or wait, I guess it's a circle intersection, not a normalization. Unless I pick the direction towards this, this edge right here. Is this always an angular bisector? My intuition says that it's not. Is it? Does this always give the same angles on these two sides? No, it can't be, because the angle changes a lot here, but here it changes less, especially if this point is in, like, Narnia or something. Yeah. Okay. Is it possible for this to not have a solution? Let me think. Okay, so if the point is, if this point is inside of the circle, it means that the internal angle is greater than 90 degrees, in which case we're not going to move it anyway. If it's exactly on the edge, it's 90 degrees. If it's outside, it's a narrow angle, and therefore that's the one that's going to move. So I guess we always know that it's outside. So that helps. I guess the next question is, does the angular bisector always point towards the circle? Which it has to, because the circle is defined by these 2 points, and the angle is always halfway between them, and there's no way to not pierce the circle there. I guess the only edge case is like if both of these vertices are at the same location, then you have a degenerate circle, so there's no circle to intersect. But that's okay. Okay, I guess it's a circle intersection then. So instead of the direction to the circle, we get the halfway, the angular bisector, I guess it's called. It looks like 2 pluses right now. Yeah, so we get this, basically this array, and then we do an intersection test with the circle. And then we end up with this point. And then that basically gives us the force vector, right? So this would be the force. And also this is like the maximum force, or like the ideal force. But then we're going to multiply this to make sure that the whole thing doesn't explode. This makes sense to me, I think. Okay, I need to drink a little bit. This does change the angle on the left and right vertex though and may make them worse. That's okay, because it's going to be an iterative solution. Like any errors should just cancel out at the very end. Like the more iterations you do, the more these things should make smaller and smaller changes, and it's going to eventually reach some kind of equilibrium. Well, it's also possible for it to be an unstable simulation, in which case things might explode to infinity. That can also happen. So hopefully that doesn't happen. Especially if you add some sort of damping term. Yes, I already have a multiplier that I'm going to apply to these forces. Oh shit, it's Thor. It's Thor. Look, it's Thor. It's Mr. Thor. He's sniffing. He's thinking. I'm sorry I'm in the way. Hello? Hey, mister? What's up? Sniffle, sniffle. Sniff, sniff, sniff. Yes, I'm bisecting the angles. I had an eyelash in my eye. It's usually not supposed to be in my eye. Hey Thor. Hey. Hello. Yeah, hello. Cat break. Yeah, he's kind of like blending into the void, so usually I have to provide like silhouette silhouette backgrounds here. Very hidden cat. I'm running out of tea. I feel like I should make more tea. Hey there. Hello. Glitch, glitch. He's glitching out sometimes. He does these little like face twitches where he's like blinking and twitching a little bit. It's really cute. I'm guessing it's just like old cat glitching. Hey. He's 17 years old, by the way. So he's pretty old. Pretty old. Old man Thor. You missed it? Yeah. Okay. I'm gonna go make some tea. Do I have my... Where's my... There we go. Why is he named Thor? Because that is the name that the shelter gave him. And when Ashley, my ex, adopted Thor, she just kept the name. So I don't know if I don't think we know what name Thor had when he lived with his previous family. I think his previous owners passed away, and then a relative took him to a shelter, and then Ashley adopted Thor, and then we lived together for like 5 years, and then when we broke up, Thor came with me. Yep, so he's just always been Thor, according to us. Okay, I'll be right back. Gonna make some tea. Oh wait, I should press the money button because YouTube has like a play ad button. Insert ad. Okay. All right, I'll be right back. Wait, I feel like there's always a stream delay, so I don't know if I should click it now or if I should click it when you sync up. Like, do I need to be late, or I don't know how this works. Okay, whatever. I'll try it. Hello. 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 YouTube Premium gang gets the chair content, exactly. Yeah, I still don't know, like, when I click the play ad button, I don't know if it plays the moment I click it or the moment I did it in the stream, like with the stream delay. I wish I knew which one it is. Okay, I'm gonna go grab my tea. Maybe I can do like a countdown, like 3, 2, 1, and then I click it. Actually, maybe the stream delay isn't too bad. But yeah, okay, I'm gonna try to do a countdown and then click it. Like 3, 2, 1, click. And if you never hear me counting down, then presumably the ad starts immediately when I click it, rather than when you see me clicking it, right? Okay, so I'm gonna try that. 3, 2, 1. There we go. Now the ad should be playing unless you have YouTube Premium, so. That should refill my water as well. Didn't get an ad. Should be immediately. Oh, nobody knows. Okay. No premium, also no ad. Okay. I wonder if it's like, it's not that I'm playing an ad, maybe it's that I'm inserting an ad location for the VOD. Is that it? I'm guessing that's it. Okay. Gonna refill my water as well. What if each iteration positions every node at the average of its neighbor's previous positions? I guess that could work. What would that optimize for? I feel like that would optimize for making them square. As in not just having 90-degree internal angles, but also optimizing to try to make them square, I think. Because then the edge length is also taken into account. In this case, I wanted to try to make it only based on angles at first. Kind of ignoring every other aspect of it beyond the constraints. Okay, all right. I believe we are ready to continue. Wouldn't that optimize for the shortest edges? Well, given that I have points that are locked in place, I don't think it would just shrink forever. Okay, right. How do I stream? How do I press buttons? There we go. No idea what's happening mathematics-wise, but it's entertaining as fuck. Good. I am glad. Or I mean, I'm glad it's entertaining. It would be nice if the math could get across as well, but that's optional. You're welcome to lurk. Thanks for your videos. Really motivated me to research and do more computer science and math stuff. Awesome. I am glad. You're welcome. And or I'm sorry, in case that was a bad thing that happened. But you did say thanks. I assume it's positive. Okay, let's try this. Let's see if we can make this happen. Is there a nicer way to do this circle intersection that's a little bit less full intersection test? I guess it would kind of just boil down to the same thing. I can probably just do a full intersection test. That's fine. Again, I don't know why I'm trying to think of optimization, because it doesn't matter in this case. Okay. Where were we? Lines and tangents are, in my opinion, the way. It could be, yeah. I do want to try to have multiple things that I'm optimizing for, and then kind of experimenting with all of them. And then also experimenting with having weights for which ones it should prioritize. Because eventually I'm gonna need stuff like this when I do UV unfolding. Okay. So I guess we are iterating through every half edge. If the half edge is if the half edge has an internal angle less than 90 degrees, then it's going to add force. And I think I want to use the same rule for all angles less than 90 degrees. So it is possible that it might add force in the other direction as well. But that's okay, I think. So then I could just use the same code instead of like trying to find which one is the lowest or whatever. I think I just want to do a blanket every angle less than 90 degrees. Or less than its ideal internal angle, which is different. We're going to have to separate those two down the line. Center plus radius times normalized point minus center. So that doesn't give the same results because I want the angular bisector. So I want this point, not this point. Your equation would give this point, which would be a straight line from the vertex to the point, but that's not the one that I want. Shouldn't the movement direction be the sum of each angle bisector, weighted by how far the angle is away from perpendicularity? I think you're describing the same thing we're looking at right now in different words. I'm pretty sure. Oh, I'm not going to use any linear solvers because I don't have enough experience using those. So I usually just wing it. We'll see how this works out. It's just going to be an iterative solve. I'm not going to use any like specific algorithms, for better or for worse. Maybe I'll do that later in case it's required, but I'm really curious how this is going to turn out. I wonder though if maybe the angular bisector isn't the way I should go. I wonder what the trade-offs are there. But it's easy enough to try both. So let's see. We are gonna iterate through, let's see, solve is gonna calculate forces. And then eventually apply forces. I'm just going to start with a single calculate forces. And then we can do the multiple iteration stuff later. So calculate forces and apply forces. Okay, I'm going to comment that out. And all right, forces. Okay, where's our half-edge iteration? We did a internal angles here. Right, this is the iteration we want to do. And we're gonna have to calculate the internal angle stuff. Okay, so we are iterating through every single half edge, which means we are going to get some half edge pointing along an edge, and we're going to need the position of the root vertex, and we're going to need the position of the neighboring vertex, or vertices. Okay, seems straightforward enough. So I guess we can just directly get their coordinates. I guess we will call them ABC, or previous self next, maybe. I guess previous self and next is has more directionality to it. Let's see, winding order means that, right, okay. So self position would be get mesh dot origin position of half edge of the half edge itself. And I guess I need to cast this. Can I just... Seriously? Oh my god, Unity. You should have added casts for this. Do I, okay, more, no, it's not a flow 2. Oh, it's a vector 3, right. Do I have it in my math library? I have vector 2 array extensions, but not vector 2 extensions. What? Really? Did I not put extension methods in here? Oh, wait. Okay. Here we go. The class was just called extensions in general. I guess this would fall under swizzling. Oh wait, I do have XY. Oh wait, because it's vector 2, not vector 3. Oh, okay. Well, I guess I am kind of missing this for vector 3. So I guess it would be this. Oh wait, I do have it for, oh, because it's the Z component. That makes sense. Okay, so that one I already have. Right, so this is the part that's vector 3. Cool. YX, XY. Okay. Is there a reason you use explicit types instead of var when declaring variables? Just preference. I just like seeing the types. There's also like, C# does have the target types new, where like, usually you would have to do something like this, right? And there's kind of like two different ways you can use a var-like thing. You can use, do it like this, where kind of the type is here, and then you don't have a type here. But you can also sort of do it the other way around with target types new. So you can actually remove the type there. So like, there's kind of two different ways to remove the redundancy of having to, you know, notify the type or like write the type twice, which is the thing I usually think is the main benefit of using var. And between these two different ways of initializing, I way prefer having the type in the beginning than having the type after the assignment. But that's just a preference thing. So I usually lean towards either this or just having the type explicitly spelled out there. Missing YZ. It's not supposed to be like fully covering all the different cases, so. Right, I was gonna do XY. There we go. I do judge you for having files with over 1K lines. That's okay. It's like it's totally fine to be wrong, so that is allowed. Okay, we need the next half edge, so or wait, this is the previous one. So that would be a mesh previous half edge. I'll have the half edge, and then the next. You know what? We don't need to write position because it's kind of self-explanatory here, I think. Get a half edge next. There we go. Okay. Cool. what do we got here? So we have the vertex locations for these 3 vertices now. So then what else do we need? We need the halfway point and the radius. Okay, I think we can use the circle 2D stuff because I think I have a circle 2D construct where I have intersection tests and stuff. I believe intersection tests, right, with the linear stuff. Yeah, okay. Isn't the naming of previous half edge and get half edge next inconsistent? Yes, but it's for a reason. So the way that I've set up the naming conventions here is that if a function starts with get and uses underscores and has like a data type here, this means that this function is getting the raw data that's stored inside of the half edge itself. If there's no underscores anywhere, it means that this is calculating a value. This is doing something more in order to retrieve that value, whereas this one with the underscores is just a grab. It's just grabbing existing data from that data type. So anytime there's underscores, it is just a raw data. But if it's anything else, something more is happening on top of that. So that's why I have this this distinction here. So it is inconsistent, but the inconsistency is for a reason in order to highlight the difference between these two. So like if I look at the half edge next, all this is doing is just grabbing the next half edge, because that's an existing property in the half edge data type. But previous half edge, that is not stored in half edges. Half edges have no idea what half edge is before them. So previous half edge is actually a search. It has to iterate through the face in order to find itself and then return the previous one. And so these two are just different operations. And so that's why they intentionally look different, so that I so that I keep track of what I'm doing. I also kind of forgot that I had tea. I'm gonna have some tea. So I guess in a sense it's not inconsistent. There are rules. Good use case for methods versus properties. Yeah, but I have parameters, so I can't use properties here. Okay. Circle. Let's see. What do I need here? I need the midpoint of the circle here. So I guess call it C mid. And that would just be previous plus next over 2. And then we need the radius, I guess C radius, and that's previous minus next. Or wait, the magnitude of that, right. Yeah. Length. Wait, do I not have extension methods for that either? God damn it. Length over 2. Okay. So, new circle. We got C mid, C radius. This is not a float 2, this is a float. Cool. So, we got the circle. Then we need the bisector here. Okay, I'm gonna get this direction in the stupid way, but that's okay, because we don't need to optimize. What do we call it? What do we call this blue vector? The It's like the bisector direction, bisect vector, bidirection. It looks like it's supposed to be bidirectional now. Okay, can someone tell me how to turn off Writer's AI autosuggest? Because I keep getting, like, thrown off by it writing incorrect code in front of me. How do I turn this off? I want whatever autocomplete was there before generative AI. Is there a way to turn this off? There's gotta be. There's gotta be some way. Good lord. Settings. AI. They probably call it something else. Do I need to search for AI with spaces? AI assistant? That's like a tool window. Wait, I'm searching among keymap. Hold on, that's a keymap search. Live templates, is that it? Oh, there's too many different things. Copilot? I don't think it's Microsoft, so I don't think it would be Copilot. Copilot is Microsoft, right? I don't want to like completely remove autocomplete. It's just that I want the autocomplete that was there before they started using generative AI. So like full line completion, is that like implied that it's the AI thing? Inline completion? Yeah. Okay. Runs entirely on your local device without sending anything over the internet. Okay, that sounds like... Wait, code completion settings page. Oh, it just takes me to the... right. Okay, yeah, what do I have here? Wait, it's already disabled. This says based on machine learning. But then here it's enabled. But here it's disabled. Okay. Do I just disable that then? It looks like you're trying to code. Yeah. ML1 is to sort the results based on how you use them. Okay. Oh, that might have been the one that also made me frustrated. Okay, so theoretically this is gone now. Equals. Okay. Neat. Thank you. Thanks for the help. Wait, bottom right? What about the bottom right? Oh, and VS Code? Oh. Yeah, I don't know what it is here. Roslyn analyzers? I don't know, doesn't seem to be anything there. Okay. There we go. We're gonna get the... Right, we wanted the bisection direction. Right, so we're gonna do that the stupid way. In other words, we are gonna do math.normalize, and we are gonna get the direction from self to previous. And then we're gonna add that to the direction from self to next. And then we're gonna normalize that whole thing again. There we go. That's the stupid bisection direction method. Okay. Cool. Now we got that. And then we want to construct a ray from that. Oh wait, yeah, I don't have a ray 2. I just have a ray 3. That's okay, probably. Intersect. Let's see. So either... Oh yeah, with a... Okay. I feel like I had a static function for this. I have these like super generic intersection tests things that I'm not super happy with. I should just remove. Maybe it's... I have two different... Do I... What's in here? Mono behavior. Okay, that's just a... That's an entirely different thing. Javier Thomas? That would not give the angular bisector. I want the angular one. Okay. I guess I'll use my weird circle 2D intersection. Oh wait, can I use line 2D? I know that I have intersect circle somewhere. Intersect circle. Where did I put it? Circle, line, line, circle. What do you mean nothing found? Okay, circle 2D. Where is it? Where is it? Intersection tests. This is the one that I wanted. Oh, I made this way too generalized. I guess this one is fine. Okay. It's just intersection test dot linear circle t values. That's good enough. But I guess the circle one is just a wrapper for that probably. Regardless, so I guess we just do. That's intersection. That's circle circle intersection. This is the one that I want. Okay, and then I pass a line 2D into it. Which would be a, let's see, origin would be self and direction would be the biter. And then that would give me 2 results, 2 points. Okay, cool. But we just need the first one, and I think we could just assume it's gonna return a valid intersection point, because I believe it always does in this case. Okay. So this would be the intersection point. Okay, that should give us this point right here. So now that we have that point, we should be getting the final force if we just do the vector from self to the intersection point. So float to force equals intersection point minus self. Cool. Then we want to add that to the all of our force data. Where do we store it? It's stored in the force point. Right. So I want to do I guess I need to know the vertex of this half edge before I can figure that out. So vert index is mesh dot get half edge origin of half edge. There we go. So what did I call it? Force point. And then vertex to points, dictionary. There we go. So then we get the point. And then we got the... Where's the force? There's supposed to be a force in here. Did I not add the force? Oh, I just never did. Okay. Force. Force. I guess we don't need to store that. So we just add force to it. Cool. Okay, where do I do the constraints for the points? Do I do that? Do I constrain the... Do I apply the constraint after adding up all the forces, or do I do it when I add the force? I feel like doing it after feels more stable for some reason, like numerically. No clue if that's true, but let's pretend it is, and then that means I'm making the right decision. Oh, we do actually want to store this in a variable, I just realized. Because some of these points are just static, so we need to skip those. So if force points dot constraint is fixed, then we don't apply any force at all. I guess that would be... I guess I could just apply that afterwards anyway, but then it would be redundant calculations. And what if my computer does work unnecessarily? That would be sad. Okay, so I guess one thing that I need to make a note of here, this assumes an ideal internal angle of 90 degrees. What? I just murdered a fruit fly. I'm sorry, fruit fly. I just don't want you to reproduce in my plants. Cool. Then we need to draw these forces, because otherwise we're not gonna know what's going on. So let's see. Where do we draw the forces? Love to see you fight with yourself about optimizing. Yeah, it's like such a habit. Okay, yeah, I guess we'll just draw the force on top of, I don't know, on top of everything. Or no, wait, not on top of everything. Maybe on top of the disks? Under the vertices, actually. The vertices should be the only thing that's drawn on top. So where... This is the vertices. Okay, so we're gonna draw them here. Draw force vectors. Okay, for each... where are my force points? Excuse me. I guess they're all in the dictionaries. What are you working on now that the bevels are done? The bevels are not done, but I am currently working on trying to find a better point distribution within the triangles. Because right now they have these like really harsh angles that look kind of bad. So right now I'm mostly just experimenting with finding a better distribution by making a like sort of simulation that's like trying to search for a better better distribution based off of some constraints. And right now, the constraint that I'm setting up is to optimize for internal angles. That's what I'm doing. And so this is visualizing the internal angle discrepancy between 90-degree angles versus the actual current angle. Okay, so now, right, and then the way that this works is that I'm going to iterate through every vertex, and then it's going to calculate a net force that it's going to apply to each vertex, which is kind of like an imaginary force, like not actually a force, but like the, it's more so like the displacement that each vertex thinks it should do to make a 90-degree angles. But then I'm adding all of them up, which means that all of these points are going to kind of fight with each other, but hopefully it's all going to like cancel out in ways that makes it like reach some kind of equilibrium for the optimal point locations inside of this. Yeah, and we've just calculated the forces, and now I just want to visualize those forces. So I feel like I had a draw arrow function. No, wait, that's in my video editing project. Okay, so that's not in here. I guess I'll just draw a line. Okay, draw a line from force point to force point plus, no wait, oh, I'm dumb. Position plus force point dot force. And why exactly is this? Oh, because it's fluid too. I don't like how my Unity plugins are using the old vector library, because all of these conversions are kind of annoying. Do I have it like a 2 vector 3? No. Okay. Is the modeling app built on top of Unity? Yes, but it's not a Unity plugin. So like this is more like a game made in Unity rather than a plugin for Unity, if that makes sense. It's basically a game that pretends to be an application. So if I can press play, I'm gonna play my game, which very much looks like something that's not a game. Yeah, so it's a standalone tool. Also, I just broke it because I forgot about my weird bugs. And the thing that I've been working on of late is bevels. So adding support for beveling meshes like this. And the thing that I'm more specifically looking at here is to find a better distribution of points that makes it look less jagged. Because this one looks very jagged and wonky. Like I don't like how there's these like harsh internal angles here. Like it looks like this should be here. That's a more relaxing position, right? And so that's what I'm doing right now. So I'm gonna try to make an iterative solver to find better locations for these vertices. Yeah. Wouldn't OpenGL be more performant? I mean, OpenGL is a like rendering platform. It's not really an engine or like, I don't know. I mean, Unity compiles to Unity can compile with OpenGL as a target. And so like you can't really like make a 3D modeling tool in OpenGL because you also need the CPU code for that, and OpenGL is just for the GPU. How does this compare to Vertex distribution of Blender or 3D Max beveling? I have no idea. I tend to not compare my stuff too much to the existing solutions. I for a few reasons, but it's mostly because like I really enjoy problem solving, and I usually like sometimes if I see existing solutions, it genuinely kind of feels like spoilers to me, which sounds stupid, but like because I enjoy the problem solving, if someone gives me the solution, they kind of take away the joy of exploration and experimentation. And so usually I don't like comparing, because then it feels like I sort of have these expectations and a target in mind, and it feels less like I'm making something and I'm just trying to catch up with other things, and I don't enjoy that. It's exactly the same way that I play video games. I'm extremely spoiler averse. Like when I watch a movie, I don't want to see the trailer either. I think the trailers is way too much of a spoiler, so usually I don't even watch trailers before I watch movies. Same thing with video games. I hate looking up anything in video games. I really, really just like the experience of exploring things on my own. So it's only if I'm like completely get stuck and I don't know where to go, or I have no idea what I'm doing, like then I might look stuff up. But usually I just enjoy the experience of like doing things on my own. Which is obviously not very efficient, but efficiency is overrated anyway. Okay, these lines should be a little bit thicker. Yeah, let's do 4 maybe. And I guess we can use the same color I used here. So forces are now yellow. What? Hey, come on. Okay. Okay. I feel like it should be drawing stuff now, but I'm not seeing anything. Am I actually running the force calculations? Oh wait, no, solver's step count is not. There we go. Look at this. Look at this. All of this makes sense to me. This looks good. I think these directions make sense. The one thing I don't like about this is that it's not optimizing for area right now. And so it's going to create way too small shapes in here. But that's okay, because now we're not optimizing for area. We're just optimizing for internal angles. It is kind of interesting that it's almost the average. Like the vector is almost the average of the vertices on that face. Oh wait, actually, I'm not orthographic. Or no, that wouldn't matter. Never mind. But it's almost. It's kind of wonky. Neat. Okay. Are you asking why I'm using C#? Wait, are the arrows reversed? No. It's only drawing them as lines right now. There's no arrowhead on this because it's just a line drawing function. So it's pointing towards the center here, from here to here. Because my draw arrow function is not in, it's in another castle, you know? Oh, because it's not common. Can you think of an example of a 3D modeling app built on top of Unity? I mean, just because it's not common doesn't mean that it's bad to do it, right? So it's kind of just like I'm picking the tools that I enjoy using and the tools that I think can get me from point A to point B, and the tools that would be catered to me in a way where I actually finish the project. Because, you know, you can sort of think about optimal solutions forever and then switch to the most performant, low-level C++, whatever solution you might want to do forever. And you're probably, or I would probably end up with a tool set that I would hate to use, where like I can theoretically get the best performance ever out of this tool set, but will I actually finish the project with these tools? And the answer is no. C++ is probably, I haven't used it that much, but it was probably one of my least favorite programming experiences ever. I did not enjoy using C++, and I really, really, really enjoy using C#, and Unity. So like, for example, the thing I'm doing right now of just visually debugging and like being able to, like, I don't know, I have a viewport, I can visually debug stuff. I can like dynamically, I have sliders so that I can dynamically like look at things and test things. Like, if I were to do this in some super low level library, would I even have a viewport? It's like, oh, probably not. Would I have a UI system? Oh, probably not. Would I have access to compute shaders? Probably not. Would I have access to like multi-threaded code that compiles to native stuff in a nice way? Probably not. And so like there's a ton of downsides, and the only upside is that theoretically I could make it a lot more performant because I'm using something low level and native. And so there's like a pile of actual drawbacks and then a tiny benefit that's theoretical. And so that equation just tells me that that's not the solution, right? And so I'm going to use Unity. And it's definitely not for most people, it's not the tool for the job, but it is for me because I enjoy using Unity. Yeah. Oh, it is kind of interesting that the forces go left here with these blue. Interesting. So I think I mentioned this during my first stream or like earlier this week. Like the thing is that like if I need performance, like so like for example, if I need performance out of this, which I do, I really, really do need good performance. Let me just disable that. So for example, let me create a torus, and then another torus, and maybe another torus. So there's a lot of elements in this scene, right? There's a stupid amount of triangles and vertices and edges and all of that stuff, right? And if I were to write the code for example, selection, if I made selection in single-threaded C# code, it would probably not be this fast. But clearly, it's fast enough for me, right? And I can even do stuff like camera-based selection, where I want to do a selection, but not select faces that are not visible. So that's a more advanced type of testing. And that's not just like based off of face normal or whatever. It's based off of whether the things are obscured by something else. That's quite a lot of data to go through. Every single face, every single thing that can obstruct everything else. Like theoretically, this is something you would never be able to do in C#, right? So what I do is usually that if I need to do this kind of mass data processing, where this has to be like real time and performant, I just do it in a compute shader, right? I do it in the compute shader, and then if I need that data in C#, I just send it back from the GPU to the CPU. And if I want to do it on the CPU, I usually do it in the in Unity's job system, which takes my C# code and compiles it to native C++, or transpiling, I guess it would be called. So it transpiles it from C# to C++, and then I get native performance out of my C# code for these particular, like very, like performance sensitive mass data processing. Like the GPU is really good for this kind of stuff. And so like, is C# too slow? If I wrote single-threaded C# for all of this stuff, maybe. And if I wrote bad C#, it's always possible to write bad code. Maybe I wrote it so that I'm allocating, you know, classes for everything that I'm iterating here, right? But I'm not, because I have a ton of experience with this and I know what I'm doing. And so you could say that, oh, but maybe you can get it slightly more performant in C++ if you wrote it single-threaded, but I'm not even writing it single-threaded. And if I'm doing this on the GPU, chances are that's going to be faster than C++, because the GPU is stupidly fast at doing mass data processing. And so it's like, I don't even need the performance that C++ gives me. I just don't need it because I wouldn't make use of it, right? What about integrated graphics? They will just suffer, which is okay. So yeah. Sorry for the long rant. Is this made in URP? No. I think it's I think I'm using the built-in render pipeline, but I'm also not really using the render pipeline because I'm not drawing anything in Unity's render pipeline, actually. All of my stuff is a custom command buffer. And so I'm not using Unity's, I'm not using any of Unity's render pipelines. Technically, the project is set to the default render pipeline, but I don't call camera.render, except for some of my debug stuff. But that's temporary anyway. C# is very fast. Yeah, the one caveat there is that Unity is still stuck with mono for the runtime, which is slower than modern C#. And sometimes you find really cursed bugs where you need to write a function that is basically a no-op. It returns the thing you pass into it, and then that fixes a bug in mono. I have run into this problem. And my ex was a compiler engineer at Microsoft, and so we were going through this very, very cursed code together. It was very interesting. They're slowly moving back to the official C# runtime. Yeah. Have you thought of programming in assembly? I mean, sometimes I would never consider programming in assembly if I want to create something as complex as this, but I mean, it's interesting to think about, but anyway, we were not supposed to look at these. Oh yeah, someone asked about the moving the selection. This is something I just straight up took from Photoshop. If you make a selection box, if you hold space, you can move the selection box. So you can kind of like move it around after the fact, which is a lifesaver, because when you like select something and you like accidentally missed some faces, you can just like do a slight adjustment. I love this feature so much. I think Photoshop is the only one I've seen it in. And it is so nice that it's possible. So Photoshop, it's hold space to move the selection box. It is so nice. Instead of having to like, ah, shit, I missed the, I need to redo the box. Oh, that's too much. That's too little. That's, like, no. Instead, just hold space and then you can align your stuff. Blender that does that too. Neat. Good. This should be a standard that everybody does. Okay, we weren't supposed to talk about donuts. We were supposed to look at this. And I have a little too many faces now. What was I using before? This, I think, right? N equals 6. Okay. Are we ready to run the simulation? To see where this goes? I'm curious. I'm so curious how this is gonna look. Okay, so we just need to write the apply forces function. Which is basically just iterating through each force point. Okay, where did I do that? I forget exactly how I wrote that. It was like the dictionary.values or something like that. Force vectors. Oh, here. Okay, force point dot position plus equals force point dot force times force multiplier. And then we set force to 0. Oh wait, I guess it's a vector. Flow2.0. Oh wait, we need to do the constraint, actually, because now it's unconstrained. Okay, that's fine. We'll just make a function inside a force point that's called apply force, and then we can do the code in there, because it's better to put the responsibility in the force point itself, I think. Okay, apply force. Have you considered creating your own OS, CPU, plus custom architecture and GPU with custom architecture, assembler, and writing an assembly so you can get maximum theoretical performance? Yeah, but like, if I do that, I feel like I'm so close to like just creating the hardware myself and like setting up the microchip factories, and because then I can really optimize it specifically for half-inch. Yeah. And then I feel like then I might as well like set up the mine to mine all the minerals that I need. Because I feel like some people just mine the shittiest minerals. I was like, oh, thanks, here's my shitty GPU. And it's got like sort of slightly impure carbon in it. Like, ugh, so frustrating. So I'm thinking like maybe I should source my own carbon as well. Oh yeah, multiplier needs to go in here. Force multiplier. That's a long word. I don't like that. Let's call it scale? Scale? There you go. Okay. So first we need to... Okay, so this is apply force, but then we first need to constrain force. Yeah. Okay. What are the different constraints? If constraint equals constraint force. Okay. Yeah. Okay, constraint force. Or do I? It feels a little weird to pass something that I already have access to, but it makes sense in my head. I wanted to get a thing and then return the variant of that thing instead of like assigning inside of it. In which case this is going to battle with the instance field. So you know what? We're going to shorten this to F. There we go. Okay. Have you already created a Bevel monad? I forget what a monad is. The answer is probably no. Okay, constraint force. So we can simply do return constraint switch and then add some missing arms. Okay, if it's free, we just return F. If it's fixed, we return 0. If it's locked to a specific axis, we return ooh, wait, how do I oh yeah, I guess it's if it's locked on 2 axes, yeah, no, then it can't move at all. Right. Because I don't really have a specific axis here, because there's like 3 different axis constraints. I have the raise here. But my axis lock mask is a mask. It's not really a... whatever, I'll just make a function. Okay, is it a... axis lock mask and then axis raise, that's static. Okay, yeah, good. Then I should make this static. Okay, static. Float to get axis ray. And then it's the axis mask, I believe. Wait, I have multiple things called axis mask. That might have been the wrong one. Did it include? Oh yeah, it's this one. Okay. Return axis mask, or no, mask, switch. Is stuff getting spicy in chat? Or are we all okay in chat? Okay, let's see. Get access ray. The only case where this makes sense is for these three, and so if it's anything else, I'm just gonna throw, which makes sense. Okay, so this is basically just returning the access rays in order. So, okay, it's a little bit of a roundabout, stupid way of doing this, but that's okay. I am also pretty roundabout and stupid. Okay, so here we have the ray. So we pass the mask into access lock mask. And then, let's see, so this is the direction, which is always from the center, which is why I never have a ray construct. So all I need to do is project it, basically. So project to vector. That's the, no, wait. We start with a point, which is the force. We're projecting the force onto the ray. Do we need to clamp it? Nah. Okay, why is this sad? Oh, this is vector 3. Wait, do I not have vector 3 variants of the, or float 2 variants? What? Ugh, okay. I wish I had modern C#, then I could generalize all of this so I don't have to have separate functions for different types. Come on, Unity, get going with your core CLR stuff. Okay, float 2. Okay, we got our basis project safe. We got project vector. Okay. Happy December. Thank you. Okay, if people are getting angry with each other in chat, please do not. It's okay to have disagreements, and I can't really find a big disagreement. Maybe it's because I have the filtered chat, but be nice to each other. Okay, we got our 2D projection going. I guess that's it. You know what? I feel like this should be an input. It's called access lock, I think, or what do they call it? Constraint. It's a lock. Okay. Probably not a good name for this, but then we can make this one static. I thought. Okay, never mind. No, it's too much effort to use. We're gonna have the cursed mix of sort of static, but not quite static. Okay. Is this correct? We're constraining the force, which reads off of the current constraint, And we're projecting it to the constraint vector, which should be correct. I guess I could make that also clamp, because it is kind of a bounded projection. Like, I could add protection here to make it actually not go outside the triangle or bypass the center. So I'm just going to add a note. But I don't think that's going to be necessary. Okay, apply force. We are doing constraint force. This is going to be either pass-through, projected, or 0. And then multiply by scale, then we add that to the position, and then we reset force, because then we've already applied it. Cool. Do you have standalone C# projects not using Unity? I don't. I think I might have played around with it like once or so, but I haven't done it much, so. Oh, hey, Kyperia is here. Good. I think there's some kind of disagreement in chat. And it might be that I'm not seeing half of that conversation because I'm set to top chat instead of live chat. Yeah. Okay. Just to set the expectations and set the stage. Kyperia worked on the C# compiler at Microsoft, and she's also started a project at one point to make a C# as a GPU shader language type of thing. And so she probably knows more about this than most people in chat. So if there's a disagreement around that, I think she's a very good judge, I suppose. Yeah, the axis mask is a bit mask. Yeah, it's a bit like redundant to have both the lock type and the axis mask, I think, but whatever. It's okay. It's okay to be imperfect. Okay, so we have our apply force, and we should just call that on every single point. I think they meant if it was locked on X and Y. Yeah, I don't think I ever get like 2 axes on there in practice, but I do get all 3 axes when the point is in the center. And so the bit mask is going to be like 1, 1, 1 if it's in the center. Otherwise, one of them is going to be 1 if it's along some axis, right? But it's never like 2 of them has the flag set to 1, so. What did I call it? Force multiplier. There we go. Okay, apply forces. We are now, but that return switch will just go to one of the cases, right? Which switch? Which one? Here? Yeah, because I'm only calling this one when the lock is set to axis, which it only ever is if only one of these is set to true, which is the one I'm getting here in the axis mask. So this is the axis mask itself. Okay. All right. Are we... Nothing is happening. Wait, where did my force vectors go? Hold on. Did I remove calculating the forces? Did I accidentally do that? Let's see. Solver step count is 0. Okay, so if I set it to 1. Oh wait, I need to recalculate the mesh, I believe, because this is based on the mesh data, not the points. That's why. Okay. Yeah. Okay. 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 Let's see, vert to point. And I would like to deconstruct this. And then mesh, set vertex position, the vertex to point, point dot position, I believe. The float 3, maybe. What? Oh my god, do I have to do new float 3 with 0 at the end every single time? I feel like they should at least allow explicitly casting a float 2 to float 3. Like, I get why you wouldn't have like an implicit cast, but explicit I feel like should work. I guess there's also... Ooh. Yeah, this stuff is a little weird. I guess I already wrote that here, but yeah, that's okay. I can fix that later. Right, so we need to recalculate the mesh after we do all of the iterations. So apply forces after here. There we go. Okay, this function is a little bit weird. It should live over here instead, I think. Okay. Okay. I believe we're ready. I believe we can finally see the iteration in action. Maybe watch it explode. Alright. Oh, this looks real bad. Hell yeah. Nice. That's fascinating. Why? Hold on, I feel like this is not even... Something's got to be wrong here, because I feel like the forces we were looking at, they were fine? Am I getting like IDs mixed up or something? Or no, wait, maybe it's the constraints. Hold on. Yeah, I think I'm mixing up the constraints. Because this point should be constrained to this axis, and it's not. And so it's the constraints. Oh god, this file has way too much code. Okay, let's see. So x, that's correct. And that, I believe, is correct too. Okay, so this, there's nothing wrong with this array. I guess it is the axis mask that is somehow calculated incorrectly. Okay. Okay, do I try to actually find the solution, or do I just offset this by one index? Because I'm pretty sure it's just an index. It's just an index issue. Because if you look at the direction that each of these take, they're all constrained to the next one. So it's all just off by one. So yeah, 2, 0, 1, 0, 1, 2. Okay. Did I offset in the wrong direction? Okay. I forget what I did. Did I increase by 1? I think I did, right? Oh wait, that makes sense. I feel like this should be 1 and 2. Oh no, it's probably not going to work this time, right? Oh shit, that's the wrong one. Hold on. No, wait, it would be 0 and 1. Sorry. Okay, 1, 2, 2, 0. Okay, yeah, I feel like this is unintuitive to me, but it could be that this is correct in this case. Because I have so many different conventions for the winding there. There we go. This is the correct step. Okay. Neat. It explodes. Hell yeah. Cool. We got our first iteration. Okay, so let's first reduce the strength. So that's the force multiplier. We're gonna set that to like 0.1. Okay, what does this look like? Oh hey, it turned into a Unity logo, sort of. In the middle. It looks like a cube in perspective. It's weird that this continues pushing in this direction. See, because I would have expected these to... Oh no, wait, hold on. Is it because this one and this one, they're both pushing as well, and the sum of those two is outweighing the sum of this one, right? It's got to be something like that. But I feel like this one, it's weird that this one keeps on drifting. I would expect these corners to stop at some point. So I'm kind of curious what the force vector looks like there. I wonder if I should save the... or cache the last force vector so that we can inspect it. Okay, so... Seems like it's going at a linear speed. Ooh, that's a good point, actually. Yeah, hold on. That might be the real problem. That is probably the real problem. That is a very good point. Yeah, so it's probably that it's not recalculating some data that I'm using to measure all of this. Which is actually the case, yeah, because I'm only recalculating the mesh. Wait, where is it? Oh, wrong file. I think I need to recalculate the mesh after every iteration. Because the calculate forces one uses the mesh data to apply that. Yeah. That was a good catch. Thank you. There we go. Look at that. Oh my god. Isn't that so satisfying? Look how it just settles. Neat. Yeah, it kind of converges around like 12 iterations or so. Interesting. Okay, what if we... Oh yeah, I never did the central triangle. That's cool. Yeah, so right now it does not care whatsoever about the area of each face. It is only trying to optimize for 45-degree angles inside. Does it converge sooner if you increase the multiplier? That is a good question. Okay, multiplier at 1. Maximum speed. It exploded. So, first iteration. And we are already at almost invalid topology here. We got some concave quads. Okay. Maybe we need to reduce the force multiplier. Look at this soup. Yeah, right now I'm just dragging the force multiplier slider. So 0, increasing. Oh, it starts going haywire at like 0.3-ish. This is kind of cute. I like this pattern. Neat. Okay, I need to save this. Kind of like the gradient in the background too, but then I can't do ortho. I guess it's okay that it's not orthographic. We need to save this for future generations. Max step count, then adjust force. Okay, step count 20. It looks like the threshold is like 0.25. Like it has to be 0.25 or lower. Which is a very particular number, which probably has something to do with all of this. Oh, it's actually kind of shaky for 0.25. But I'm guessing it's like maybe 0.25 perfectly ensures that the shakiness cancels out. So what if I set it to 0.125? Now it's looking more like a linear conversion. Not conversion, convergence. What if I do 0.24? Oh, wrong slider. What? Wait, did it just delete my mesh? Oh. Well, Something about native arrays happened. You know what? I'm gonna just press play and then leave play mode, and then maybe it'll fix itself. There we go. Gonna go back to crying over my own code. Oh no. Doesn't the threshold depend on the distance it needs to move? I mean the multiplier is it's a multiplier of whatever existing force is there. So I would guess it's independent of the subdivisions. Okay, cool. I appreciate this. So what if we change the different subdivisions? We can sort of ignore the ones with the triangle in the middle. We can sort of ignore those because I haven't handled that case. This looks pretty good. Yeah, I think apart from the fact that the center ones are so much smaller, this looks like a pretty good distribution. And also because of the fact that like the edges, the tangent direction of these edges, they actually do kind of point to the opposite vertex. Which is what I also want, even though that's not a constraint that I set up. So it's kind of like accidentally doing the right thing there, which is cool. I like that. That's neat. Do we think this is a somewhat good distribution? Still trying to figure out if I should try to optimize for area as well. Are you using this as intuition for making an analytical solution, or will it stay as an iterated one? Probably just stay as an iterated one. And I think, like, honestly, I could probably just cache the most common ones, like up to, you know, n equals, I don't know, 16 or whatever. So it's, or I could just calculate them like on the fly the first time you need it, and then you have it cached. Because this doesn't depend on the shape of anything. It's literally just, it's just based on barycentric coordinates, and they're going to be the same regardless of the actual bevel size or anything. Could a similar approach be used when you tackle UV unwrapping? Totally, yeah. It's something I have, I'm also going to do for stuff like unfolding, right? Check areas in 3D, not flat. Well, then that kind of removes the ability to pre-compute it, right? And it would be nice to not have to compute it real time. Like if it looks good enough with a barycentric coordinate space version, I think I'm going to stick to that. Go bevel something. I haven't implemented this in the actual bevels yet, unfortunately. Okay. So I can't just like easily test it. It is interesting how the explosion is so sharp, is like so sharply specifically once you get to 0.25 and slightly above. Interesting. Okay, seems like 0.125 is the optimal here. Okay. Is this. I'm trying to figure out, like, if I were to also optimize for area. Yeah, right now it doesn't optimize for area at all. It is purely an angular optimization right now. Oh yeah, never double check the constraints. But it looks like everything is sticking to their constraints, I think. Yeah, I'm considering adding area now. Oh, actually, what if I start with a different distribution? Kind of curious if like the initial conditions actually matter. So let's do, okay, starting with naive, starting with projected. It does actually slightly make a difference, but it could just be that I need more more iterations. What's the point of area preservation? Well, I guess there's multiple different ways of thinking about it. Well, one, you don't want to have faces that are too small in the middle compared to the outer ones, because generally you want to have a somewhat even, like, textile density across your meshes. But it could be the case that that's a fine trade-off, that you would rather have that. I guess it's not technically directly related to textile density, but you know what I mean. I am also kind of curious if I should do some kind of constraint on squareness. I wonder what that would do. I guess what it would do is that it would probably squish these points towards this axis and these points towards this axis too. And it would probably slightly stretch these to be bigger in favor of making these more square. Because right now they're kind of rectangular, right? Like the aspect ratio of these are not fully square. Squareness might make the center faces smaller. Almost certainly, yeah. I'm kind of surprised this worked so well, though. It's very satisfying. Neat. Looks pretty good. Looks pretty good. Well, okay then. I guess I need to decide if I want to do further experiments or if I'm just gonna say that this is good and call it a day. Because this does seem pretty good. Can't imagine a scenario where I would need to preserve the area, only if I'm doing like really, really detailed meshes. Well, I mean, in general, it's kind of nice to have your polygons have the same area if you're doing edge flow shenanigans, right? Because usually you don't want to have like a very, 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 like a like a super high density somewhere else, and then low density and low poly somewhere else. Like usually you want it to be relatively consistent across your mesh, unless you're like intentionally adding detail for like places where you really think it needs more detail. But like in this case, this is usually going to be across like a circular or like a spherical surface, in which case I feel like the detail levels should be the same across the whole thing. And so it feels like it's kind of weirdly prioritizing the center in terms of detail level, when I feel like it shouldn't prioritize the center. It should equally prioritize the entire surface. It's not that much of area discrepancy in this method. Yeah, no, it's very close. The only thing it would do, it would like grow the center a little bit and shrink the boundaries a little bit. I think that's what it would do. Just want to let you know we have your stream up in our doctor's office area at our hospital because we'll work better listening to you. Doctor's area? I don't know if doctors find this very helpful to do like barycentric coordinate adjustments. Would the faces at the center be made larger when actually on a 3D surface? Like automatically when using this method, or because keep in mind this is just in the barycentric coordinate space. This is not as applied to the thing, so it's gonna look a little bit different. Overlap between CG and medical imaging. I have actually considered, like, anytime I get like an X-ray or anything similar, I'm like, can I have that data? I want to play with shaders and like a brain scan. What if I can render it volumetrically, real time? Okay. I need to do some stretching and a little bit of chilling before I move on to area. I do want to try the area weighting to see if to see what that looks like. I think it would make a very slight adjustment to this, and that's okay. I've gotten CT data from one of my scans. You just have to ask nicely. Oh, it was so funny. My sister actually did this at some point. And I forget the way that she asked it. Yeah, I think she asked if she could have the 3D model of a thing that she did, or a thing, or from an appointment at a doctor's office. And I think, like, she just wanted a 3D model file, right? But I think they actually gave her something ridiculous. Like, it was either like paper printouts of images, or was it actually like a clay model or something? I think it might have been like a clay model and maybe images as well on like physical paper. When she just wanted a file, like a 3D model file. Yeah, I'm pretty sure it was like a physical model. Which is like, if they went through the effort to like make a physical model or something, I'm guessing they might have resources for that at the place, but like but like she wanted the digital version, but like it's kind of hard to like criticize them and be like, hey, oh no, I don't want this more like higher effort thing, I just wanted the low effort one. I don't know, it was silly, kind of funny. You asked for heart monitor data and then printed it out hundreds of pages? Yeah, exactly. It's like that kind of stuff. I guess you have to be like super explicit and be like, hey, I'd like the digital data, like the file itself. Okay. Let's see. What do we do next? Do I fix the odd numbering algorithm stuff? Or do I try the area weighting? I feel like I should fix the odd numbering stuff because it's kind of sticking out like a sore thumb right now. So I think I should fix that first before I do anything fancy. Yeah, area seems way more fun, and I think that's why I should do that after this. So what should the internal angles be here for the central triangle? I guess maybe it actually doesn't really matter that much to, like, if the triangle tries to optimize for 90-degree internal angles. I think that's okay, because I think it's kind of going to cancel out anyway into like a 60-degree internal angle anyway, I would guess. So I think all I just need to do is add the central triangle, because I just haven't done that yet. Because now the mesh just has a hole here. There's no triangle here in the middle. How did I actually do that for the mesh? Oh, maybe I never did. Yeah, maybe I never did that actually. Okay, so if it's odd, if it's got an odd number of subdivisions, I need to get the innermost ring and add a triangle. I think that's it. I think that's actually not a whole lot of work. So where did I put that? Where do I generate the mesh? Great floating vertex. Here. Okay, this is the thing. So if qt dot is even is false, right? Because it's odd. Yeah. If that is false, then we just need the innermost one. So what would that be? That would be I'm honestly surprised that you can use squares for modeling. I would have assumed you could only use triangles because any other poly doesn't necessarily form a plane. Yeah, like when you export the model, it generally converts it to triangles anyway. So there is a bit of ambiguity, like how you want to triangulate like any quad. But there's heuristics for that make it generally like tessellate the way you would want it to. But like once it's rendering on the GPU, it's almost always triangles. What am I doing? I want the shell. Tetras in shell. Yeah. Okay. Let's see, I guess I have verts there, so for each tetras in shell, and then qt dot shell count edges -1, and then int for tetra And then we do verts, I guess this basically. Add tetra, and then create face inside of those vertices. I guess that's it. Okay. Oh, what? Oh, wait, did the force multiplier reset to 0 or something? Anyway. So starting point, 20 iterations. Zoop. I love how it explodes. Oh yeah, it could be that I don't update the mesh and on validate, that's true. Although solve should do that, but maybe I had the solver step count set to 0 or something? I don't know. Okay. Unvalidate isn't called when recompiled? Really? I thought it would be. But I also have on enable, where I guess I just do this one, but I don't call solve actually. I mean, I guess solve should just have the default positions in there anyway. I thought unvalidate was also called when the inspector shows up for the first time after recompiling. But I could be wrong. Okay. Does it matter if the triangle has a different internal angle expectation here? Because where do we calculate forces? Forces? Calculate forces? So like the ideal angle, should I just set it to whatever the number of edges in the triangle, or yeah, edges or vertices in the triangle it has, or in the face? Because now I think it's trying to optimize for 90-degree angles in the triangle as well. But I mean, it doesn't look bad. I guess the only other thing I would wanna do to like mitigate this issue is to just make it bigger. Which would be kind of like the area adjustment. So maybe I'll do the area optimization. Okay, use more subdivisions. Oh, it shrinks to a tiny little triangle on the big subdivisions. Guess it's not that tiny. But it feels like it's less than half of the size of the outer ones. Oh my god, it looks so nice when, oh, not when it does that, but when it like relaxes the whole mesh like this. This is so satisfying. I love this. This feeling, this is what it was like to UV in Maya. UV mapping in Maya was so nice and fun and goopy. I remember Maya. Okay, I'm gonna fix my force multiplier to just go from 0 to 0.25. Yeah, let's let us use 25, even though it kind of seems like the threshold was at 25, but it's not fun anymore to UV map in Maya. No, because I don't own Maya anymore, because it costs a lot of money. Okay, force multiplier is now going up to the limit. Yeah, you can see that it starts wobbling as soon as it goes up to exactly, like very close to 0.25. That's when it starts getting wobbly. Like anything below 0.24 seems perfectly consistent. I love seeing this propagate outwards like this. It's kind of like ripples here, right? Yeah, especially when it's close to. When it's close to the maximum value, I think that's when you get maximum ripples. It kind of reminds me of like diffraction type ripples. But yeah, as soon as I reduce the multiplier, it's a lot more smooth. That's neat. I love this. Paid for a home license in Maya years back. Yeah, I used to have a Maya license too. They priced me out. All the options are gone. Yep, it sucks. That's why I'm working on this, because I miss Maya and I don't want to give Autodesk money. And I didn't really like Blender, and so I figured I would go on a somewhat unhinged journey to try to make my own Blender. Neat. Cool. Okay. What makes Maya's UV editing better than any other UV editors? Well, the distinction is less now that Blender had its latest update, but interactive unfold. Interactive unfold means that when you were unfolding UVs, you were looking at exactly this type of animation in your UV editor. And this is satisfying. This just feels neat to see this, right? You're just like, hell yeah. That looks neat and it feels goopy and good. It's like you're watching it solve problems in front of you in a very smooth and nice manner. Maya did that when you unfold UVs. You literally had a slider that you could drag and watch the iterations happen. I liked that. It was just very satisfying. And also, Maya never had the selection issues that Blender was plagued with for most of its lifetime. Okay. I guess we've fixed that. Right, I want to do the area normalization stuff. How do we do area normalization? So I think for area normalization, we take the current quad or polygon or whatever, and then we check the area, and then based off of the target area that it's supposed to have, we expand it. We just multiply it from the center to make it bigger. And then based off of the difference between the current and the target, that's our force vectors that we're going to add on the edges. Just tighten all the edges. Well, it has to be based off of area, like the target area. So yeah, I feel like that should work. Let me draw what I mean. Excuse me? Can I have any amount of anything on here? There we go. Why do they need to have the center the same area? Because it's going to look like a more consistent triangulation, or quadrangulation, I guess. Because generally you would want to like equally distribute detail along like a uniform shape, not concentrate detail in specific locations. Usually like concentrating like higher poly counts is usually done for a specific purpose, because you want to have more like geometric detail in that location. But in this case, it should be uniform. Like the detail, ideally, should be uniform across the whole thing. Okay. I wish YouTube chat had like the usernames rather than the handles, because I don't know everybody's handles. Because I know that there's a, do you pronounce it Javier when it's like Xavier with an X? It's Javier, right? Because I'm like, are you the same one as in the Discord, or I'm not sure. But I'm guessing your actual full username would, maybe, I don't know. Wait. GZ? Xavier? Xavier? Do you pronounce the R? Anyway. You're not on Discord. Okay. Oh yeah. I'm just gonna drop a link to Half Edge's website. So if you want to join the Discord for Half Edge, there's a link inside of that link. If you want to hop in, the Discord is basically the waiting room for Half Edge. But there's a bunch of people who are excited about Half Edge, and I post updates in there, and I do post notifications when I go live, that kind of stuff. I did rounded edges corner in my slicey mesh package, and I think I used a quaternion based interpolation. Yeah, I think that works as long as you can always fit a sphere into the corner. But you can't always do that, right? So you do need some kind of stretching and squashing. So, and then you also want to like have the continuity constraints met and all of that. But yeah, I did consider if I should do something like that as well, but I don't know. I feel like anytime I use a circle or a sphere for a situation where it feels like it should be a circle or a sphere, I feel like it's almost never the right solution. The moment you have something that's where n equals 4 instead of just n equals 3, or n equals 2, I guess. Oh, we were going to do the area thing. Okay, so the ideal area would be like the total area of the whole thing divided by the number of faces. Like, that's the ideal area for one cell, right? So that's going to be the target. So this is going to be the goal area for the whole thing, right? And when we then know the goal area, we're going to have some kind of quad. It's going to be like a weird shape or whatever. We don't care about the shape for this constraint, but so let's say we have this as our data, or like this is the shape we have right now in the iteration. And then we measure the area of this one, and then we see, okay, is this greater than or less than the ideal area? If this is too small and we need to make it bigger, then we can just grab the average, the center point of this, and then we basically take this whole thing, multiply every vertex by some amount to get like the ideal size, so that we kind of get the area that we want for this thing. So we know how much we need to multiply all of this by in order to reach the target area that we have here. Let me just make that orange. Yeah, and this directly translates into the vector offsets that we had before. So it can tap into basically the same system. It adds forces to these vertices. A desire to go to that specific point. That's what I'm thinking. The only thing I'm not entirely certain of is how should I do this at the boundaries? Because some of these points are just always fixed. And I feel like I should take that into account. But maybe it doesn't matter because it's iterative anyway. But then maybe the weights, it's going to be like weighted to... Like, I almost feel like if the boundary of the triangle is here, and these two vertices are fixed, I feel like it should, like, scale from this point outwards. Instead of scaling from this point. But if this is the top quad, in other words, the triangle is like this, it's even more weird. Maybe I don't have to care about it, because like, even though these only move halfway than what they should, in the next iteration, they're going to keep on moving in that direction anyway. So I don't think I actually have to care that much about... I don't think I have to care that much about the boundary conditions. I think it's going to like kind of automatically get handled. I'm new, but I followed some of your videos that helped a bunch for work with vector calculus stuff and some Vex tooling. I did work and would like to say thanks a bunch. Thank you, and I am glad it was helpful. First stream I catch, I loved your educational video regarding geometric algebra and curve continuity. I'm glad you liked it. How do you change a white rectangle in orange with the brush? Oh, that's, I have a long enough cable for this? Oh, absolutely not. Okay. I have a Stream Deck on my desk. I have like an extra mini keyboard, the Stream Deck, and then I have a color palette on that Stream Deck. So I can just press buttons to switch between my colors. And it's all just hotkeys in Photoshop. So the Stream Deck triggers hotkeys, which is very useful because sometimes I do live lectures, and so it's nice to be able to like do this without having to like manually select colors or whatever. It is very, very handy to be able to do that. Okay. All right. I think this works. I think we are ready to do the area stuff. Okay. How do I, let's see, how do we combine all of these? I guess I would kind of want a slider for whether it should be internal angle based or area based. And if you put that slider at 0.5, it's going to equally weigh both of those. I think that would be cool to have a slider to control that. I think actually Maya had that for its UV unfold. It might have had 2 sliders actually for making it edge length based. But 2 sliders is not the solution for that. You should have like a it's literally like a triangle, like a barycentric thing. It should be like a triangular slider where you have a triangle and then you have a point inside the triangle that you can drag around. Which, I mean, you don't usually do that in UI, but that would be cool. Then you get a proper barycentric weighting. Okay, so let's see. Yeah, let's make that slider. So, do we have separate force multipliers for? It's probably the same, I think. Yeah, this one should be like a blend. Triangular color wheel does it? That's true. That's actually true. That's true. I think Photoshop has that, right? Yeah. There we go. Yeah, this is what the slider should look like. Where each corner would be a different priority. So it would be like area, edge length, angles. And then you would basically decide priority here. And if you put it dead center, it weighs all of them equally. And then it can change the weight inside of that. Oh god, incorrect. Hue cube? Brightness cube? Color wheel? I forget what I did. Or forget what my default is. I don't know. I don't know. Casco. So this slider goes from, I guess it's either angle versus area. There we go. That's what this slider is called. I think it was the top one. Hue cube? Okay, yeah. I'm familiar with this one. I feel like it was that one, yeah. Okay, angle versus area. So that would be changing the priority. So if this is 0, it's only angle based. So I guess we would need to separate the forces here. We would have the angular force total, which would be, oh, I guess this is not a float, or no, it should be a float too. Oh, wait. Wait, hold on. Do I... Or no, yeah, I don't have to have totals here. That's okay. Yeah, okay, so it would rather be that we have weights here. So weight for angular, which would be 1 minus angle versus area. And then we wait for area, which is angle versus area. So these two add up to 1. So then we just, let's see. Wait, where do I, is it in apply forces that I reduce it later? I think so, right? Oh yeah, it is. Okay, so we got the angular weight, and that's multiplied here. And I guess we can optimize. Look at this. If the angular weight is greater than 0, then we do all of that. There you go. Isn't that nice? Look at that little optimization. This does not matter. The only thing this does is make my code more indented, which is kind of annoying. So probably not a good optimization. I'm not optimizing readability. That sucks. Are you a freelance developer? Sometimes I do freelance work. I guess technically I'm a freelance technical artist. Usually, almost always, I do stuff within game development. But my personal projects are usually tools for game development rather than making my own games. Because I turned into a math nerd. You can always return if W angular is less than 0. No, because I'm gonna do the area-based stuff now. Okay. Separate calculating forces by angle and area into separate functions. That would probably be the right way to do it. But too late. It is impossible to fix that now. We are knee deep in tech debt over here. Okay, mesh dot faces. And then what are we doing here? Yeah, it's per face, I think. So face ID. It's preparation for third function for line length. Yeah, that's sort of what I'm thinking too. The only thing with line length is that I don't actually know what I should. I don't know the optimal line length. Like for area, it's pretty obvious that this is the ideal area. But for line length, I don't know. I don't know what the optimal line length is. Is it like... like, is the optimal line length dependent on the line? So like, the optimal line length for this one, should that be this length divided by 4? Is that the optimal line length? Or square root of area? That's actually kind of interesting because that's not just optimizing for line length. That would also optimize for squareness, which is not something I'm doing right now, that I was kind of curious to try. But I guess that would like automatically optimize for squareness. Yeah, I wonder what that would do. Let's do area first though. Okay, now that we have the face, I guess we need the center. So that would be mesh dot face center average. Oh my god, really? 2. Okay. Oh wait, I added a... Didn't I add an XY? Oh, this is actually a float 3. That's nice. Okay, we have the center, and then we need to, let's see. hold on. We iterate through every vertex in the face. And then we need to figure out how much do we need to, oh yeah, we need the area. That's what we need. So that's the current area. Or no, area current. Where do I have that? Oh wait, that's a constant actually. That's just barycentric.area. No, that's the total area. Never mind. Sorry, I'm dumb. Face area? But the ideal area is this, divided by the number of faces. Skirt area would not be good for the center triangle? Probably not. These streams have been great, thank you. I'm glad you like them. I honestly have no idea what the target audience is for my streams. I have no clue. But I'm glad y'all find it interesting. Okay, yeah, we need the ideal area. Didn't I calculate this at some point? Oh yeah, wait. Yeah, here. Okay. This is the thing. Right, I was debugging this earlier. Or no, wait, this was just summing the current amount. Okay, whatever. Okay, float, area, target, or do we call it ideal, maybe? That would be barycentric.area divided by mesh.faces.length. Okay. And then we need to figure out how much do we need to scale this thing to get it to the correct area. Ooh, I feel like this is a... I feel like I could maybe make use of my weird lerp functions for this, because this is that weird relationship where you have something linear and something square, and you wanna sort of interpolate across a linear dimension versus a square dimension. But it's basically the amount I need to increase the scale of this is actually the square root of the difference. Is that it? When it comes to a linear dimension, right? Because it's kind of like we have a linear dimension times a linear dimension. That should equal some area. And we want to find linear times x, which is its current area times something, should be the target area. So basically, I should use the same, what did I call them? Ideal and current. Okay. I guess this is area current. This is the multiplier, or the scale. And then ideal, we're going to call that I, not to be confused with the imaginary unit. So I guess it would be like, is it I over... No, wait, what do we want to find? We want to find a multiplier for the length. Oh yeah, that's it. Right, Okay, so the thing is that we want to multiply a vector that represents the position of the thing. So it's actually, we want to find a scale S to multiply a linear dimension by in order to get an ideal area size of I. I think that's it, right? So basically we have L squared and S squared, right? So we take the ideal divided by the current area, which is length unit times length unit, and then we get the scale squared. So we need to do the square root of this in order to get the linear scale, I think. I think that's it. This makes sense to me. So we get our scale, which is math dot square root of area ideal over area current. Okay. And then we iterate through all the half edges of this face. Mesh dot half edges of face, face ID. He. Okay. Yeah, I guess we just get the delta from center to the current vertex, and then multiply that by scale, and then add the center back in to get the target location. And then we do the difference between the actual position. Something like that. Okay. So I guess we need the position of this one. So that would be mesh dot half edge. What? Oh yeah, wait, it's origin position of half edge. There we go. Scale is not the distance I move the vertex. The scale is what I multiply the local position vector by to get the target position. Okay, so let's see. So this is the current position. I yearn for a modern actual trench broom or alternative in the Unity editor. Well, that's kind of what this started out being, but now it's standalone. But you can hopefully use half edge in a similar use case down the line once it's actually released. Okay, so the target position is, let's see, that would be position minus center multiplied by scale plus center. Yeah, okay, and then what we want is the delta from the position to the target position. So that's our force. Force equals target position minus position. I believe that's it. So then we add that to the total force. We don't know the force point. We need to know the force point. Okay. I already see that I need half edge in my professional life. I'm sold. Great job. Thank you. I'm like kind of low-key terrified of releasing this because the thing is, like, I've been pretty successful releasing Unity plugins, and this is the first time I'm making a standalone plugin, or it's not a plugin, it's a standalone tool. And I have no idea what the market looks like for that. Like, if I were to just continue making Unity plugins, I think that would be pretty stable, because I know that that's worked pretty well for me before. But yeah, that should be W area. Thank you. But releasing standalone is terrifying. And like, my competition is Blender. Like, that's not easy competition. Blender is an extremely like competent piece of software at this point. And so like competing against Blender is rough, especially because Blender is going to be free. Half-edge is not going to be free. So like the immediate question that people ask for good reason is like, why would I use half-edge when Blender is free? And so I think for me, I just don't know what it's going to look like to market this. Like how do I market something that on paper has way less features than Blender? Like, it seems like it has way fewer features, and I will never compete with Blender on features because I work alone. So like, I don't know. It's this really tricky balance. So I think there's like two major things I can do from my end. One of them is just show, don't tell. Like, I will never be able to write a list of features that looks better than Blender, but I think I can show workflows that people will tell immediately by looking at it that it looks more intuitive than Blender. And I can sort of lean into some of these things of like Blender looks intimidating, but half-edge looks less intimidating, at least right now, you know? But apart from those two, I think I pretty much have to rely on word of mouth. So yeah, because like you're gonna trust your colleague or your peers who tell you that this tool is nice much more than me telling you that it's nice. Like, me telling you that my own software is nice, of course I think it's nice, but you know, that doesn't mean other people think it's nice. But yeah, I don't know. It's like a huge time sink and a huge risk. But I think if I get caught up in thinking that, like, getting too worried about all the unknowns and all the things that work against me when it comes to making this, I think I kind of have to have a stupid optimism and just hope that it's going to work, like financially, because otherwise I wouldn't make it. Because I think like on paper, it makes no sense to work on something like this, and it's been done before, and those projects failed. One of them was even made in Unreal Engine, which was kind of funny to me. But I can't really base this off of that data anyway, because 2 data points is not data. I don't know. I'm kind of approaching this the same way you would indie game development, where it's kind of the case with a lot of indie games where you're not like making something that you think is going to be like super marketable and the best thing to be releasing in terms of the market. So a very common thing you do as an indie game developer is like, I'm going to make a game that I like and that appeals to me. And then you just like pray to the forces of the universe that other people are like you. And that's sort of the way that I think with this as well, with half-edge. Like, I want this tool, and I'm just kind of hoping other people also want it. And so, yeah, I'm just praying that there is a there's a crowd out there. But yeah, like it could also be the case that like, oh, what if I sell 100 copies and then it peters out to like 1 copy a month? That's just not going to be financially viable. So, and that could happen, you know? Like, I didn't even know how many people are in my, like, half-edged Discord. Like, let's say all of those people actually bought 1.0. That wouldn't be sustainable either. Like, it all hinges on whether it can, like, take root and spread. But I genuinely have no clue. I've been trying to write this single function while talking, pretending I can code while talking, which I can't. I see this as what Sprite is to Photoshop. Yeah, yeah, or sort of what Procreate is to Photoshop as well. It's like a specialized variant. Okay, I really need to go to the bathroom. So what about releasing it for free and open source and finance through donations? That is a very quick way to never make any money ever. Donations just don't work, unfortunately. Okay. Alright. I will be right back. I've had to go to the bathroom for a really long time. I just never did because I got so caught up in stuff. Oh, I'm going to click the add button. Mate, because this is a good ad break location. Look. Yeah, the thing is like, oh, sorry, I forgot the microphone. Yeah, like donationware is like, it's like, there are so many people who like get software for free, and if it's optional to pay, it's not like, you know, 3 out of 10 will decide to pay for it if there's a donate button. It's more like 0.01% will actually pay for it. And out of all of these people who didn't pay for it, like almost all of them can actually afford it if it would have been priced at some price point. And so like it's just bad. It's just overall bad. Like donations are generally very, very hard to get any big amount on ever. Does Patreon count as donations? I mean, that's sort of a like, I don't know, sort of. It's like a subscription donation type of thing. Yeah, like for my Patreon, that's like an overall bucket for donating or like supporting my work, right? But my Patreon, you get like nothing on my Patreon. It's not like you're buying access to something, because it's just kind of like a support, a way of supporting the stuff that I do. Pay what you want is better than donations. Yeah, at least if it's like when you get it, you're actually faced with a window where you need to enter a dollar amount. And I think like, I honestly think if the dollar amount has a default amount that's like reasonably small, like I don't know, a cup of coffee or whatever, like I think most people, if they have their credit card information already there, I think a lot more people will pay. But if instead there was like a download button, and then separately from that there's a donate button, I think way fewer people would actually pay for it, even though they could afford it and would afford it and would pay if they were faced with the like default value input window. Yeah. Yeah, I think the JetBrains licensing model is interesting. I think yeah, I've been thinking about this a lot. I just really, really hate subscription models. Like, financially, I should have a subscription model if I look at it purely from a financial perspective. But, like, I really hate it. So, like, I don't know. I would feel shitty doing that. I don't know. I don't want to do that. I think, like, I don't know. I like it when you can like pay once to own something, and you don't have to present it as a subscription. Pay $100 for a year of updates, then you'll keep the last version forever. Yeah, I mean that's sort of the JetBrains model, which I think is pretty good. That's like definitely the better type of subscription model. Like the one where you never have access to it ever feels really scummy. I don't know, because if you think about like Maya, if you have a Maya license and you're paying monthly, and the moment you stop paying, you never ever have access to it again unless you start paying again. And I feel like that feels like such a shitty way of setting it up, because like if you're like almost in a monopoly, which I don't know, companies like Adobe and Autodesk certainly want to be, like there's not a good incentive for you to improve your products. But I think if you have this type of thing like JetBrains does, where like you do have access to the version that you had at a certain point, even if you stop the subscription, and then you can resume the subscription if you genuinely feel like the later versions have something that you want. I think that's kind of fair. It's like the best type of subscription model, I think. Again, assuming there's new features that you want, but even if there are no new features, you would just not pay that subscription and you would keep your older model. I really like that model. But then that like practically that gets into weird like weird territory around how I manage licenses, and I'm not entirely sure how I would even do that or enforce it, right? Hold on, there's cats happening. I think it would be interesting to have an upfront cost, the first purchase, and you own that, and then a small fee to get an update. Yeah, there's like technical issues there. Like, I don't know, let's say yeah, it's similar to the DLC model, but the tricky part there is that all of these DLCs need to be independent in that case, and they would have to be like plug and play. Like owning certain ones, then like I don't know, like all of those would have to work independently. You can't just make a new version and they all are interdependent and you do stuff that's affecting, that affects it all across the board, right? So that has like technical issues. But I think, so the thing that I've had in mind right now is a pay once type of model, like perpetual license. And then when I add features, I'm gonna just make it more expensive. Like the price is based on how much stuff is in there that's useful. And then if you get it early, then you get it early, I suppose. And then you won't have to pay for updates. So that's sort of how I think about it. Not like DLC, I'm more like buying a small fee to get the newest release. Yeah, that would make more sense, I think. I like the way Bitwig does it. You buy it and own it forever, and updates for a year. Yeah, that sounds like the same thing that JetBrains has for their stuff. Bevels are not done, no. But we're on a bit of a detour right now. Okay, I am actually pretty hungry. I'm just gonna double check to see if I have something snackable. What? I just clicked a bunch of stuff. What? Kind of alone in this, but why are free-to-play games are overlooked? Dota as a games as a service has a pretty good monetization system. I'm not sure if you could incentivize people to get like granular, like cosmetic stuff. Like you can't really do that, I think. I don't think, like, I don't know. I feel like a game is something you do like as a community and together with friends, and it's like an entertainment thing, and there's probably a lot more like incentive to buy skins or whatever, because you get to like do things with friends and show it off to friends or whatever. So I guess like it's closer to something like a free-to-play game that has no multiplayer or anything online. It's a single-player free-to-play. And that alone, I think, would immediately reduce the incentive to get like cosmetics, and would reduce the longevity. I don't know. And then if it's not just single player, but it's also a tool and not a game, there's even less incentive to get things like skins or whatever. So I just don't think it works for tools. It would be funny though. It would be kind of funny. Yeah, I was thinking about stuff like, oh, do I add achievements? Like, if I release Half Edge on Steam, do I add like Steam achievements? Trading cards? You get like a trading card for like the Bevel button. Like, hell yeah, I got the Bevel trading card. I think doing cosmetics for a tool would be pretty much like having donations, but they give you an extra bonus reward on top. Yeah. And yeah. Yeah. What did I need the Vertex ID for? Hold on. What am I doing? Oh wait, it's just so that I can get the... Right, it's just that, I think. And then I get the force point. Okay, yeah. Okay. Oh, you know what I really want to do? Okay, so one thing that's kind of like been bothering me when it comes to making tools is that, as opposed to working on games, is that in tools, there's like certain amount of creative work that you just don't really get to do when making a tool. And one of those things is sound design or like sound effects, right? And you can see where this is going, right? Like, what if I did sound effects for Half Edge? Like, what if I treated it just like I would a level editor inside of a game? Because if you have a level editor in a video game, you would put sounds on every single action that you do, right? Like, think of the level editor for, I don't know, Trackmania or something. Like, that has sounds for buttons and placing objects and deleting objects. And that was, it just got me thinking, and I was like, it's kind of interesting. I wonder what it would be like to do an SFX pass on Half Edge. Not like, and not in like a comically over the top way either, but like actually trying to be subtle about it and tasteful and making it just feel right for the things you're doing. I think that would be super interesting. It's very non-standard though, and I think a lot of people would turn it off. It's kind of like when you go to a website and a website has sound and music, you're just like, oh geez, why does this thing have you know, music and sound when I didn't expect it to. So like it would be really unexpected, I think. But I think it could also be really cool if you do it right. Again, it has to be very tasteful and very subtle and subdued, because it is, you know, a tool to make it to help you create something, right? But I don't know. I think it's possible to do it in a way that would work really well. It's a feature Blender doesn't have. That's true. Yeah. Like, I don't know. It can be something like, I don't know. You know when you like pick up a bunch of like blocks in Minecraft. You get this like sound. That's what I remember. Maybe you don't actually, but there are probably things that are more like, right? If you're doing a lot of things. So imagine those types of sounds when deleting a set of vertices. And you like match it to the number of vertices that you delete. Wouldn't that be kind of cool? And if you delete just one vertex, it's just one, like a tiny or something. Like it doesn't even have to be like overwhelming. So not like those, you know, yeah, like those like IDE plugins with explosions and VFX and all of that. That's over the top. I'm thinking like actually trying to match the vibe. That would be super fun. I'm considering doing that. But I think, but yeah, in reality, it's probably one of those things people will turn it off immediately, which is kind of sad. Especially if you ask ahead of time. If there's a pop-up window, like a startup, like a setup first time pop-up that asks you for like initial settings, if there's a checkbox that says enable sounds, I think 99% of people are gonna uncheck that box before even hearing the sound effects. I think most people would just be like, oh god, no, please, no sounds in my tools. I don't know. I just think that most tools that have sound, they usually have really bad sound design. And so I'm thinking like, what if you do good sound design for tools? I think that would be really interesting. I don't know. It's just something I think about because it's super interesting to see if that would be like possible. Yeah. Yeah, it would be subtle. Like definitely not overwhelming. If you make a marketing video, oh, that's true, actually. It would actually be like a good thing for like sharing videos on it. That's true. Didn't even think about that. Good thing you're thinking about the marketability, more than me. Okay, let's see. Force, we're adding to the force point. Okay, I guess I do have the constraint here, but I really don't need to do that. People seem to like keyboard sounds on phones. Yeah, that's probably the closest equivalent, actually. Or like there's some like messaging apps that also make little noises when you're sending stuff. Yeah. Do I need to check for 0 area? Nah, we're not going to hit 0 area. We're not starting out with degenerate triangles. Isn't it the artist's job to make those sounds? It might actually be, yeah. Okay. Okay. Are we done? Is this it? I feel like I'm about to do something, but I think this might be it. Because we're adding the force, scaling it by the area weight. I think this is it. I want to try this. I want to see what happens. Let's go. Oh wait, I boiled some water. Hold on. For my snacks. I did find some snacks. found this like carbonara snack pot. Wait, there you go. Carbonara snack pot. Probably the nutritional value of a small rock, but that's okay. I'm hungry, but I don't want to stop the stream, so maybe this will keep me going for a little bit further. Okay, it's supposed to sit in hot water for 5 minutes. Okay. Get some more tea in the meantime. Salt is an essential nutrient. So is iron. So, like I said, nutritional value of a rock. Probably contains a lot of essential minerals in there. Okay, force multiplier. Oh, wait, it's set to area already. Oh, hold on. Oh, goodness. Huh. Okay, so now it's set to area only. When I increase the force multiplier, kind of goes haywire in the middle. Why is that? Well, I guess it has to expand the center ones. Yeah, it would be nice to have the force vectors now. I guess it's like the only way to increase the area. Because it's getting pushed inwards here. Okay, let's see. So we just do angles. It kind of settles here. And then if I start making it area based, oh, it actually starts out pretty well. And then here it starts exploding. Oh, that's interesting. Yeah, if it prioritizes area only, it starts exploding pretty quickly. But if I put it at 70%, 70% area based and 30% angle based, it's looking pretty chill. Like, I feel like I should increase the max number of iterations because I'm kind of curious if it keeps on gooping. Well, that's the wrong slider. Oh, geez. No! I can't undo. Will the alpha version of the stat be shared with the community to test, or do you have more ideas to test before going to the community? I have a private alpha that I want to do. Extremely optimistically, I wanted to do the private alpha this year. So that one, there's no public sign up for that one. But I'm not sure when or if I'll ever have a public sign up for like a test version. I'm not sure. Wait. I changed the wrong slider. I was gonna set this one to 100. There we go. Sorry. What was I gonna say? Oh my god, I just completely dropped out whatever it was I was talking about. Wow. Well, it just ejected from my brain. Private alpha, yes, thank you. Okay, yeah. Yeah, I don't know if I'm gonna have a public sign up for that at some point, but yeah, hopefully a private alpha soon. But that's been, that's kind of been like by invitation only from my end. Because I'm trying to prioritize people who have industry experience and like current and active use cases and projects. Especially people who have projects in development that could make use of a tool like this. That's pretty close to my target audience. Because if you have a public sign up, ooh, this one did really well with a lot more iterations. Hell yeah. Look at that. Okay, it just took a while for the changes to propagate outwards. That's nice. Oh, that's so satisfying. Look at that. It like ripples out. Neat. I love this. Oh. Angle-based. Area-based. And then halfway. Neat. Neat. I really liked it at 0.8. Like that seems like a good balance between the two. Oh yeah, I was gonna say that like public signups have a tendency to get a lot of people that are kind of new and want to test it out for the first time. And it's fine to have people who are new to it test it. But for that kind of test, I think I would want to be present and like watch how someone does using it for the first time. But it's not going to be super useful for like general usage and feedback. I think I want to make sure that the general usage is in the target intended use case, right? Yeah. Okay, there's one thing that I really want to do. I think the area visualization that I have right now is not very good. So I want to actually visualize the area deviation as well. Which I do, but I don't draw it in a very nice way. This is the one. How will this work for different triangles? Wanted to explode on some triangles and not on others? You mean like a different shape of the outer triangle, like the whole overall thing, or? The answer to that is that the outer triangle is like completely independent. It's just gonna map this to whatever triangle you have. Because this is just purely in barycentric coordinates that I'm doing this. Okay, instead of just drawing a tiny little disc, I'm gonna be drawing a quad. Maybe. But it might be a triangle, so I need to take that into account. Let's see, so... mesh dot... what did I call it? Edge count of vertex? No. Face... oh my god, what did I call it? Of face. It should be something of face. Has to be a count for this. Count half edges in face. There we go. That's the one I wanted. So eye face. So we got the side count. And then if side count equals 3, we want to draw a triangle. Else if side count equals 4, we want to draw a quad. So I guess I'll just do a for loop. For each, no, wait, we can't do that. Okay. Half edge root is mesh dot root half edge get face root half edge. There we go. High face. What? Oh, get, not set. Okay. The mesh dot next, or half edge next of roots. There we go. You know what? Most of these are quads. I'm not gonna care about one of these being run unnecessarily. That's okay. This gives us 3 half edges, or 4 half edges, but maybe 3 if side count is 3. And then I guess we just need the positions. Float 2, V0 mesh, half edge, origin, or origin position, half edge roots, dot XY. Okay. It's a little boilerplatey, but that's okay. Half edge 1, half edge 2, half edge 3. And then we can finally draw this. So draw dot triangle V0, V1, V2. And then, oh, come on, really? Okay, I guess I'll make them float 3, even though they're not really 3D. And then draw dot quad. We add V3. Wow. Wow, wow. Amazing code. Oh, do I not need the face center? I guess I'm not drawing anything there anymore now. Okay. Now it should display the entire area of each face. Hell yeah. Although it should probably not draw on top of on top of all the other markers, because they were kind of subsumed by this now. Okay, force vectors, and this is, what are these? Oh, the vertices, right? Okay, I should just make some separate functions for this. Void draw face weighted. Oh wait, draw face. What do I call it? Draw areas, I guess, is the way to do it. That would be this. Draw areas. Oh, ideal area per face. I guess we'll just scoop that inside. And this is draw vertices. Draw force vectors. Okay. I feel like draw areas should be at the very bottom. So, yeah, here, basically. colors are leaking again. Why are my colors leaking? Oh yeah, because I didn't do it using draw.scope. Or at least I think this is where it was leaking. Zoop. Oh yeah, I need to eat my carbon iron. Okay, I feel like the internal discs here, they should scale by the size of the whole thing. It should be like a multiple of the outer edge length, I think. So like this distance divided by 5 or something, maybe? So that it kind of scales with the n here. So where are my, oh, internal angles, this is it. So the, where's the radius? Radius, oh, it's just straight up 26. I guess this was actually based off of pixel radius, but we're gonna change that. It's gonna be draw dot radius space is gonna be in meters, and then we set the radius to barycentric dot edge length divided by n, and then we multiply that by, I don't know, 1/5. So divide by 5. Okay. I guess I could scale it on a per like face basis, but okay, so now, yeah, this seems reasonable. Okay. So what this is showing now is that where the whole thing is red, it means that the area is smaller than what the average area should be. And so this ring here, these quads have they're very close to the correct area. And the blue ones are slightly too big compared to the ideal area. So I guess that's so satisfying to watch. It's just equalizing everything. A pretty high solver count now, though. If the angle colors middle was the, if the angle colors middle was the background of the specific tile, yeah, but then it's not useful for what it's supposed to show. Or not as useful, and it'd be hard to tweak it to be useful. I appreciate this. Okay. Optimizing by angle, optimizing by area, and getting absolutely wrecked by area optimization. For sake of consistency, can you flip the colors for a larger or smaller area? Wait, what did I use for the angles? Oh, small angle is blue. Oh yeah, that's true. Wait. Why did that not change? Oh, I changed the angles. I'm stupid. consistency has been reached. I guess maybe I should change the multiplier for the intensity of this. Why did I cap it out at 0.5? I guess 0.25. Wait, am I stupid? What was it for? Oh, I meant 0.75. There we go. Okay. I just wanted to relax the colors a little bit. It was a little intense. Look at that. Isn't that cute? Neat. Oh, salad? Hey? Hey, salad. Okay. So if I just do angle, it kind of keeps the... Oh, it's interesting how the area, when I just optimize by angle, the error for the area is kind of like shifted away from the edge centers to the vertices. It's kind of interesting. Yeah, it's really like it's taking the area error and turning it into a sphere or like a circular circular shape instead of a triangular shape. Huh. It's pretty wild how it just explodes when I pull this one too much. Huh. Will we be able to see these visualizations in half-edge? I want to add visualizations like this to certain things, like textile density, or I don't know, any type of data you might want to like visualize on a mesh or in your UVs. Because it's kind of easy to add stuff like this, so. And also, I want to see it, because it's kind of fun. But maybe not this particular visualization, but... That's interesting. So now I'm kind of curious, what would happen if I were to try to optimize for... what would that be called? It would be like... Yeah, if I optimize for regularity, as in all of them will try to approximate a regular polygon. So it's kind of like I'm optimizing for edge length, but the target edge length is the sum of the lengths of all of the edges divided by 4. That's the target edge length for a given edge in a given face. So what if that turns into a force? Because then I feel like what it would do is that it would basically try to make all the quads square and all the triangles perfectly triangular. Because right now I feel like I like the way that this looks, but I don't like how it's only square out here and in the middle, but this region right here, they're all kind of, the aspect ratio is kind of off. And so I'm kind of curious about trying to have a way to fix the aspect ratio of these. That would be awkward at the corners, no? Yeah. I mean, there's no perfect solution, so it's always going to be a trade-off. Parallelograms could also happen. That's true. That's true. Yeah, parallelograms. Yeah. So that strategy of just caring about edge length is actually not necessarily going to make them square. Feels like distance to the triangle center is a key thing here. Oh yeah, I guess that would be the better heuristic for that. Like, yeah, you would want all the vertices to have the same distance to the center. Although that would actually not solve for regularity, because these 4 vertices probably also have the same distance to the center. So that doesn't actually optimize for that. But I guess it's like, if I optimize for same edge length around the whole thing, while I'm also optimizing for 90-degree angles, it would try to not make like a rhombus shape or trapezoids or parallelograms, right? So like, if I'm just optimizing for regularity, that could happen. But if I'm also optimizing for internal angles, it would avoid those situations too. Yeah. I think we're onto something here. What about multiplying the force multiplier by the inverse distance to the center? Yeah, I think it's actually a slightly, I think the solution for that should probably be slightly different. Because I think the problem that's happening here is that it tries to expand the area here, but it's expanding from the center of the shape itself. But it should really expand from the center of the whole shape. And then it's kind of the opposite for the outer ones, where like, if it's trying to scale from the center, it's going to push these in ways that's just not possible anyway. So like, these 2 vertices kind of just get half of the force that they should be getting, because these are not going to move anyway. And so I feel like there's some kind of thing where I probably want to like shift the origin that I use based on how close it is to the edge versus how close it is to the center. I'm not exactly sure what I would use as a heuristic for like where exactly to put that bound. Maybe like, because I would want it to be kind of continuous. I guess maybe I would use like, based off of the direction to the center, I get the furthest away and the closest vertex. Hold on, cat things are happening. Salad. Hello. 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 Ow, 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 buddy. Okay. Okay. Hey, buddy. Okay. Oh, so my overall point was that would be, I think that would increase the convergence speed. Because now it converges very slowly. And I think that's contributing to that, because we're wasting half of the force by the edges, and we're wasting half of the force near the center. So like shifting that origin that it's scaling from, I think would help. I guess the only like kind of weird thing is that I'm not entirely sure where to place it. Oh, you know what? Maybe I get the... Okay, this is really dumb. But I think it'll work. Okay. Hear me out. Alright, so we got the whole triangle, right? And then in this triangle, we are inspecting one cell in this triangle, right? And then this cell, we want to do this scaling thing of like, we have a target area and we have a current area, and we want to expand it or shrink it based off of that area. The problem is that we always use the center as the origin of scaling this thing. Jesus Christ, Salad. Salad. Hey, Goober. Why did he jump over the gate into this room, and then 5 seconds later, he jumps over the gate out of this room? Can you make up your mind? Yeah? Do you have a mind, Mr. Man? Yeah? Did you forget where you put your brain cells today? Yeah, maybe he forgot where he put his brain cells. Not easy to be Salad. Salad's got a rough life. Okay, go find your brain cells, buddy. Hello? What was I talking about? Oh yeah, the cell. So, oh god damn it. Salad, I am trying to draw. Yeah, I am trying to draw. Okay, so Salad. I'm trying to draw. Stop eating my pen. I am trying to draw. Yeah? Yeah? You little shit. Yeah, you little shit. So, okay, so you have a cell in the triangle, and then this cell, when scaling it so that you have some origin, no. You're hopeless. This little man. Okay, let me just remove my BRB message because that's not applicable anymore. This little guy. Hey. Yeah? You're kind of disruptive. Mm-hmm. Here, what do you have to say for yourself? Yeah? Want to talk to stream? Detain the cat in one hand and draw with the other? It's pretty difficult. I could maybe try, but... Okay, Salad. No, don't lie down on top. There's an enormous cat on my desk. I guess I never finished my carbonara noodles, or whatever this would be called. Mm-hmm. Hey, Salad. Hello. Yeah, I'm trying to stream. I was trying to draw, but there's a little guy. There's a little guy. Yeah, that's you. You're the little guy. You're in the way. This is where I really wish I had a better tripod so that I could like tilt the camera, but it's kind of tricky to do that. Okay, Salad. Okay. I think we can at least do this. No, don't hit the microphone, buddy. No. Why is my child like this? You're unruly. Yeah? Unruly little man. Well, excuse me. No, don't eat the microphone. No. Aren't all like that? Not all cats. There's some cats that are kind of proper. They know what behavior is acceptable and unacceptable. Salad is not one of those cats. Ah, this little guy. This little guy. No. No, don't eat the shock mount. Don't eat the microphone. Stop chewing on the microphone. You are chewing directly on top of the microphone. Do not. It's metal, buddy. Yeah, you're not supposed to eat metal. How do you feel about leaving optimizations as a last task for any project? Yeah. I mean, in general, I think that's usually a good idea. I mean, it probably depends on what you're working with, but like you would want to do the kind of optimizations where like if you're making a game and it requires a type of mass data or mass processing, and you want to make sure that that works ahead of time, it might be good to do that, do like early tests to make sure that like, okay, the scale of this game requires this type of thing to be performant. But in general, like optimization is one of those things that's relatively easy to fix afterwards. Like I feel like, I don't know, in the first half of any project, I feel like it's way more important to optimize for readability, and like in general good code, whatever that's defined as. Because like optimization has a tendency to sometimes make your code less readable. So yeah, but I don't know. It just depends. It depends on your workflows, your preferences, if you're working alone or in a big team, or I don't know. And I don't know if like if you're making like banking software, that probably has an entirely different workflow than what I do for games. Even if it implies rewriting big parts, for example, from CPU to shaders. Usually, yeah. I mean, if it's so slow that you're unable to test, then of course you need to do that earlier, but hey Salad. Hello. Oh my god, Salad, you are so in the way right now. Okay, I should re-enable this text because there is a snack break, also cat on my keyboard. Also, there's a cat on my keyboard. There we go. It's just the truth. No chewing the microphone, no chewing the pen. What is Salad allowed to chew? I think Salad is asking the very same question. Like, what is he even allowed to chew, if not these things? Little man. I really feel like I should get a better tripod if I'm gonna start streaming regularly again. The problem is that, like, the camera can get pretty heavy and lopsided and weird. Because I have, like, a teleprompter attached to it. And, like, I would need some kind of, like, I think it's called a video head. Like a tripod head where, like, you can tilt it up and down without like unlocking the whole thing so that it just rotates freely and can like fall down. You would want it to have like smooth operation while also remaining fixed when you let go. I think it's called a video head. I just need to... The whole stream has been scripted. Exactly. I just have every word I need to say. It's like on that teleprompter. For cat camera? Exactly. Because I want to be able to tilt it down. So we get Salad camera. I guess I could just get a second camera, because I have like an old webcam that I barely use. But I could like plug that in and have that as like the dedicated cat camera whenever there's cats happening. Okay, well I guess Sala got interested in Gumpy over there now. So now I believe we're out of cat jail now. So much fur on my monitor now. Oh, he's gonna probably jump the gate again, and I'm gonna have to help him down again. Yeah? You gonna jump the gate, Salad? Are you? Okay, okay, look at this, look at this. All right, and then we wait. Yeah, I know. Yeah, okay. Absolute goofus. Goofus of a cat. Right on cue. I mean, I could see his brain cells churning inside of his head, so... What's the gate for if they can just jump it? Luckily, Salad is the only one who's jumping the gate. For context, I have 4 cats. So Toast and Salad, they are brothers. And they're like 3.5 years old. And then I have Thor, who's an elderly man. He's about 17 years old. And then I have a foster cat, who I literally found on the street, and they had no identification or anything. I tried to find an owner, and it's now been 2 months, and so nobody's reached out, and so I basically have a 4th cat. That cat is named Gumpy. That's their nickname right now. And she doesn't super get along with all of my cats, and so that's why she's separately... she's staying separate right now. That's separated by the gate. The only cat who's jumping the gate... Well, Thor is too old to jump the gate. I don't think he'd be able to. Or he probably could if he was, like, had enough adrenaline. But Toast could definitely jump the gate. He's done that before. But... He doesn't jump. He's very curious about Gumpy. He's interested in Gumpy, but he doesn't want to jump over. Same thing with Gumpy. Gumpy doesn't jump the gate either. She's curious about the other side, but she's not jumping. Salad is the only cat that's jumping the gate. And luckily, Salad is also the only cat that gets along with Gumpy right now. So Gumpy and Salad, they can hang out just fine. But Toast and Thor, they can't hang out with Gumpy. They're still a little bit too aggressive with her. That's the story of why there's a jumpable gate that only one cat is jumping over. Which I'm very glad that he can get along with her. And he's the one who's jumping the gate. I'm really glad that Toast and Thor aren't jumping over all the time. But yeah. I really wish I had like better a better setup to make them get used to each other. Yeah, it's sort of sorted itself out, but ideally I would like for all of them to stay in the same space without fighting with each other. And it's a little difficult. I'm not entirely sure what to do next. Or like how to do the next steps I should probably do to make them get more used to each other. Okay. So like I watched a bunch of videos about like how you introduce cats to each other. Like I watched a ton of videos like that. But the problem with those videos is that they sort of assume you live in a house where if you close a door permanently, you still have access to the rest of the apartment. And I don't live in a place that's big enough to have that kind of a setup. So like if I barricade a door, I'm also gonna have to go through that door in order to like enter and exit the room, which in my case is the gate, right? And then I also need to like set up a gate where, ideally, if your cats are aggressive with each other, you want to make sure that they don't have visual contact anymore, but you want them to be able to smell each other. And so a common thing is that you would have a barrier that where smell can go through, kind of like a cloth barrier or something, but the cats can't go through, but obviously you might want to go through. And then the idea is that you want your cats to hang out near that gate, and have positive associations with the smell that they can smell near that gate. So usually that would be something like, if they're food motivated, you would feed the cats on either side of the gate, where they can, they get a positive association smelling the other cat while eating. Yeah, the reason that's wanted is because you want to associate that smell with positive feelings, like smelling the other cat, right? And the reason you want to avoid visual contact is that visual contact is a very, very striking and threatening thing to see. If a cat is staring at another cat, that's generally considered a threat if they're standing still, like perfectly still and staring. And it's very, very, very easy for that to like, even just happening by accident. But yeah, I need to figure out some way to like attach a piece of cloth probably on my gate. But I can't find my sewing kit. Like I had one at some point. And so like I would probably need to like sew it onto there somehow, but I can't find the kit. And if I don't have that, how do I attach a piece of cloth? I have a blanket, but if I hang it over the top, it's not long enough to go all the way down. So I need like a reverse blanket with reverse gravity from the bottom, but I don't have that. So like, I don't know, it's, it's like a weirdly, it feels like such a simple problem, but, and then also of course, I need to go in and out of the gate. And so it can't be a solution that kind of like locks in the state of the gate, because I need to be able to go in and out, which means I need to be able to deform it and like open and close. But it can't be too flexible because then the cats are going to be able to pry it open. I don't know. But I was also considering like, what if I just build a door, like a literal door, like just a wooden frame. And then I like attach hinges on it that matches my like real doors. And then I can maybe like buy some kind of mesh thing that's like you can slide it open, or like kind of like blinders in a window actually. But that's a lot of work, and I just haven't done it. I know someone with 3 cats and 1 dog. Everything is accessible to everyone. Seems to be going all right so far. Yeah, I mean, it all comes down to, it's not about the number of cats or the number of dogs. It's about the familiarity with each other and the familiarity of the territory. So the problem is that cats are very territorial, and bringing a new cat into your household is something you have to be very careful with and do very delicately. It's actually easier for cats to get along with dogs than for cats to get along with other cats. Because dogs and cats aren't competing for territory. Dogs are not even close to as territorial as cats are. But if a cat has a rival cat, they're competing for the same territory. And so you need to make sure that they know that all of the space belongs to all of them, and it's not about your space and my space, right? Which is kind of the problem right now for me, in that I kind of have a very big distinction between your space and my space, right? Yeah. But then again, right now I have it set up so that Gumpy is in one half of the apartment. My other cats are in the other half. But overnight, my cats are allowed bigger access, and then Gumpy stays in the bathroom. But just overnight. Which works okay so far. But yeah, it just kind of sucks. I just wish I had a better setup and that they were more fine with each other. Yeah, especially because I'm obviously growing attached to Gumpy. I don't wanna send her to the shelter. I think it's a matter of time. 2 months for adapting is very little. Yeah. Yeah, I think part of the problem is that Gumpy seems to be very aware of how smells work. Gumpy is the new cat? Yes. She does this thing where, like, Gumpy is avoiding blankets. And I think it's because all of those blankets, they smell like my other cats. So for example, when she's in the bedroom, she will never ever lie down on the bed. She will literally avoid all the blankets, like hopping up on the backrest of the bed, walk on top of that, which is kind of narrow and hard to walk on, like go out of her way to not touch any blankets, and then she lies down on a stack of cardboard boxes along the wall. And she'll sometimes sit in the windowsill or whatever. Notably, smells tend to stick to fabric. So I think she's actually avoiding the smells of the other cats, which is not good, because they're territorial and they associate allegiance with smell. So ideally, I would want to mix their smells as much as possible. But smells just don't stick to hard surfaces very well. Yeah. I've heard of some people do stuff like you get a blanket and just rub it all over one of the cats, get another blanket, rub it all over the other cats, and then you swap the blankets and then rub them all over again just to smear the smell all over. It just, to me, I just feel like that's so rude. Ideally, I would want them to do this kind of scent swapping consensually, you know? Because what if I take a blanket that smells like my other cats and then rub it all over one of them, and then they just panic or something, or they get confused, or I don't know. It just seems so aggressive. Yeah, I think one thing would be yeah, I should wash some blankets or something. Maybe even with a different type of detergent, just to kind of neutralize it, and then give that to Gumpy and see if she would lie down on it. Because she did actually lie down on a sheet that I'd cleaned relatively recently, right as she got here the first time. Um, yeah, so maybe I should just do that some more. Like, give her something that like smells a little bit more neutral that she can kind of capture as her own. And then once I have that, I can take that blanket and just toss it over my boys that are grumpy with her. I don't know. I don't know. Anyway, sorry for a cat detour. Oh yeah, I did brush them as well. Oh yeah, one thing I did was I was brushing Gumpy's fur, and then when I gave my boys food in the morning, I put the brush with Gumpy's hair on it next to their plate so that they would kind of get her like odors while they're having their breakfast. Yeah, I was hoping that would make a difference, but I'm not sure. Or like maybe I should create this little ring, like a ring of fur just put around their like bowl that they have in the morning. Kind of like some unhinged witchcraft summoning ring full of cat fur. Just to summon the good vibes. Okay. Is she the only female? Yes. I'm also not sure if she's spayed, because again, we have zero information about her. But one can assume that if she doesn't have a microchip and she doesn't have any ID in her ear, she's probably not been to a vet. So yeah, which probably means that she's also not spayed. I was a little scared for a while that she might actually be pregnant even, because like she seems to be like of that age where she would start getting pregnant. And like who knows, maybe I found her because someone kicked her out because she did mate with a cat or something. I don't know. But it's been about 2 months now, and that is about the amount of time it would take for for cats to reach a spot where it's obvious that they're pregnant. So I don't think she's pregnant, so that's good. Anyway, the thing that I was gonna say was that what if the center we use for scaling in the little patches we have in our triangle, what if we shift that based off of how close or far away from the center or the edge we are? So like if we're close to the edge, we would want the center to be like here. If we're close to the center, we would want it to be here or wherever. But I guess then the question is like, what do we use to base that off of? And then I was thinking, what if we can get like the bounding the bounding equilateral triangle. That was deeply not equilateral. Whatever, pretend this is. Not a bounding box, but a bounding triangle. And then based off of how close each of the edges of the bounding triangle is to the actual triangle, sort of imagine it like this, it shifts the origin inside of this triangle based off of that. Maybe. I don't know. It's not ideal. Percentage of distance between center and edge. I feel like it needs to be bounds based. Because if it's right up against the wall, the center is still not 100% near the edge. So it would need to be based on like a min or a max or something. Not entirely sure. Anyway, I wonder if I should probably stop the stream soon. I feel like we made some pretty good progress in this very isolated issue. Maybe I should... I do really want to try to make them regular. I still really want to try to do that. Maybe that's the last thing I'll do. I'll try to do the regularity optimization, or the edge evenness, which I guess that's going to be the edge optimization. Yeah, let's do that. That's what we're going to do. Food coma setting it, not from this tiny bucket of carbonara. This was barely any food. Probably less than a tiny packet of instant noodles. Okay. So how do we do this? So we had a slider for angle versus area. But now we're basically doing like a barycentric type of weight situation. So we're gonna have a slider for angleness, angle priority, angle prio, or yeah, angleness sounds funnier though. Angleness, areaness sounds weird. Areacity, areality. Area, I guess areaness. So either I do this and then I calculate the internal angle, or edge lengthness based off of these two numbers, and I have like a normalized barycentric coordinates, or I have 3 sliders and then I just normalize afterwards. I think 3 sliders is a lot more intuitive actually. And we're gonna rename these by angle, by area, by edge. Okay. So then we need to calculate the weight for each of these. So weight, edge, and that will be based off of these 3 values. Okay. So the sum of all of these the sum of all of those should be 1. Oh, do I do the normalization in onValidate? I don't know how much the sliders are going to fight me if I do that. Because like setting one of them to 0 is going to be weird. It might make it so that the UI locks up if I do the normalization there. I'm still kind of curious. Okay, I'm going to try doing it, see what happens. So I'm basically just going to do this, I suppose, to normalize them. Okay, how impossible are these sliders going to be to use now? Oh, super impossible, because we got errors here. Oh, I guess they would be the weights directly in that case. So if this works, in which case I want to rename these to the weights, because I like that better. Oh my god. I don't care super a whole lot about those. Okay, so the first thing that it's going to do is probably set them all to 0 point, or like a third, right? Oh, come on. Did I not name it angular? Oh, I did angle. Excuse me? Oh, Jesus, there's way too much code in this thing now. Wait, why are these sad? Did I mess up some weird bracket somewhere? What? What? Excuse me? Excuse me? I'm so confused. Why did it suddenly lose track of all the math functions? Okay, copy, undo, or like, what, did I like accidentally drop a using or something? No, I have Unity Mathematics here. Oh, now it works. Okay, well, cool, great. Maybe get your shit together. Jeez. Okay. Now we got weights here. It's actually relatively tweakable. At least as long as I don't set any of these to 0, it's kind of cooperating so far. I'm a little scared what's going to happen if I set any of them to 1 or 0. Because then it kind of gets a little degenerate. Had to leave for a couple of hours. What did I miss? You missed a lot of cat talk, and I did optimize for area. So this is the area optimization, which kind of freaks out when it's a little too high. But if I drop it a little bit, it's kind of relaxed, you know? Okay, I'm gonna set the edge weight to 0. Okay, so those two are now working, and I can increase that. It's actually working pretty well. Okay, angle to 0. Then this gets locked to 1. I guess they don't have to add up to... I guess they don't technically have to add up to 1. I guess technically I don't even have to normalize these. It just feels like I need to. But what if I just don't? That's actually okay, I think. I guess it's just like a way to avoid overshoot. But yeah, this is the area optimization. It's very satisfying to see this. Zoom. It doesn't converge super quickly. I do have some ideas for trying to make it converge faster, but what was I doing? Oh, edge lengths. That's what we were doing. Okay. So we have the angular weights, we have the area weights, and now we're going to do the edges. Okay. I guess we can maybe do that within the same loop, actually. So yeah, aspect ratio is so edge length coupled with the angle is gonna enforce aspect ratio. It's gonna try to make them square. So as long as you have both, you're gonna get that pretty much. Okay, so I guess for that we need to add up all of the lengths of the edges, and oh, actually, I just realized we can maybe combine these two into the same operation, but that's too much work right now. Probably getting too tired to do that, so I'm gonna do it separately. Okay, so this is the area-based positioning. And then we need to do the edge length adjustment. And there's multiple different ways of doing this. I think I might just do the naive, stupid way of optimizing for it. So, okay, so here's my stupid optimization. So I'm thinking, if we have, okay, so let's say we have a quad that looks like this. And then we basically take all of these edges, line them up like edge to edge, theoretically, mathematically, not like actually. I don't know, it would be pretty long, I guess. Something like that. And then just take the total length, divide it by 4. And so then it's going to try to target. Let me just move this. So then it's going to try to target an even distribution of lengths. Something like this. So then all edges should try to be this same length. And there is one way to, like, I could sort of combine this with the area optimization, where like I actually make the edges that length as part of the same like expansion. But that seems like too much work for something that might actually work with a hack. So I'm thinking all of this is just going to be comparing the two lengths. So obviously this one is too short. So then based off of this edge, it's going to add forces outwards to these vertices that gets it to that length. And then exactly the same thing for the ones that are too long, where like, okay, this one needs to be shorter. So it would add forces inwards. That was way too long. Inwards like that. In order to reach the target length of this, right? So then that would be ideally the same length. Ooh. So this would be our target length, X. There we go. And so if I just do this for every edge, adding forces like this, I think that should do it. I don't think I need to do anything more complicated than that. Yeah, let's do that. So then I guess we can just hijack the same loop to calculate the total perimeter first. So that's 0. Let's see, origin of half edge, and then we want the origin of the next one. Next, so mesh dot next half edge next of half edge. Perimeter. There we go. How would you take into account edges that can't move? Their forces would just be nullified. So right now I don't have any special treatment for this. Okay, total perimeter length is going to get added to based off of the distance between these. So I guess it would just be position minus position next, and then we want to get the length of those. And then we have the exact same loop, but this time we know the perimeter length. So this is going to be the edge. What's it called when the sides are the same length? Is it equilateral? Like regardless of whether it's a triangle or not? Because that's the thing we're optimizing for. It's not really optimizing for like an ideal edge length or whatever. Okay. So do I have... No, okay, whatever. Oh, perimeter length should be plus equals. That is true. Thanks. Okay. So we have